So developers are looking further outside the availability zones, including the green belt, and Greystoke is a good example of that. They were planning a £1 billion campus which recently got rejected. So growth is accelerating outside of London. This is driven both by continuing demand for cloud services, but also AI workloads, which require larger campuses and higher densities. It's just not possible to do these in the availability zone. So we've seen announcements from hyperscalers, operators, and even the UK government about large-scale campuses outside of the south. Microsoft announced a $2.5 billion investment over the next 3 years to expand its AI data center footprint. Google recently announced a $1 billion data center investment. And the UK government is building a 900 billion supercomputer for AI research in the University of Bristol. There's a lot of activity in the north, especially around Manchester, which we think is a key location and interesting site. Not just because I'm from Manchester, but I think it does have many positive attributes, such as large population, strong SME base, strong connectivity. It's the largest APC and AI hub outside of London and the Oxford-Cambridge Arc. You've got the BBC campus up there, it's a university city. And we've had recent announcements of investment going into Manchester, such as KO Data, who announced $350 million investment last year. Global players like Equinix are developing in Salford. And you've even got smaller retail colo guys getting attention from institutional backers, such as UBS-backed Datum, who acquired Teldata, and Luna Digital, a smaller player that received investment this year. But there's a question over customer types. I think KO Data has been incredibly successful in attracting HPC workloads in Harlow, which is outside of those key availability zones. Historically, hyperscalers have liked to co-locate around the main internet exchanges and connectivity hubs. The question is whether Manchester will be the place for hyperscalers, or whether there'll be an extension of London, perhaps into the north and the east, or maybe South Wales will be a hub where you've got NGD, Microsoft are already there, and it's slightly closer to Slough. So a slightly separate trend moving away from hyperscale. We've seen investors backing decentralized models to capture more localized demand, and you may have heard the phrase metro edge. These are sites of kind of 2 to 4 megawatts in tier 2 and 3 cities. There's been a lot of investor attention from funds and the like. Enlighten is a platform backed by I2. They bought a portfolio of 10 data centers last year across the UK called Proximity. Paulson is doing the same. That business was acquired by Antin a few years ago. It was mainly a cloud service provider, and it's shifting towards infrastructure. What's interesting about it, you've got new players as well. Asante was a carve-out from Daisy data centers backed by Invesis, which is a PGGM platform. But what's interesting about some of these deals are that they were carve-outs, and we've seen carve-outs from telcos and cloud service players to take advantage of the higher multiples in the sector and recycle capital to delever balance sheets and focus on more strategic initiatives. It's still a very fragmented market, and there are a number of players, and we expect this to continue, that funds will continue to sweep up assets. I think the Midlands and Birmingham is underserved, and it could be a focus. There's also a disparity between the multiples we're seeing for these retail colo businesses, especially carve-outs that don't come with a management team, but retail colo business versus hyperscale businesses. Obviously, hyperscale businesses, the hyperscalers come with strong credit ratings, longer contracts, sometimes 15 years, versus retail colo, different business models. The retail colo models are more diversified from a customer base, but shorter contracts and higher pricing. So I've put some emerging areas of potential investment. Some are just for interest, I think they're further down the line. But on the left-hand side, there's an interesting business called Deep Green Energy that received £200 million of investment from Octopus earlier this year. They started by trialling the heat of swimming pools by using AI servers, which give off a lot of heat. And they were very successful, and now they're going to roll that out into the UK. And they're also planning on building data centres to heat local district networks, which I think is a great thing. And they're going to give the heat away for free. So that could mean that we have local data centres really on the edge in your local communities. The next trend is one we're seeing in Europe that we haven't seen in the UK, perhaps it might come, and this is partnerships with energy providers. Green Mountain signed one in Germany with KMW. Mainova is the largest utility provider in Frankfurt, and they've created a data centre subsidiary and now in the market raising finance. There are also companies like AQ Compute, which is backed by Aquila Capital, which is one of the largest renewable investors in Europe. A couple of other trends which are probably further into the future. Micro Edge, there are companies developing small containers to be super close to the end user, and we're talking about kind of 200 kilowatts, 300 kilowatts. I don't think the use case is necessarily as accelerated as retail, as AI, but maybe it's one for the future. And data storage, some businesses are trialing the use of data storage through holograms, for example. It sounds very futuristic. Microsoft has also got a program, but this is something that's happening. It could fundamentally change the way we think about storage. So I don't know how I'm doing for time, but a few conclusions and outlook. I think one thing we haven't mentioned is the large scale of campuses and investment that's needed. Liquidity is becoming an issue for larger deals as platforms continue to grow. So contracts are bigger, demand has increased, and we need deeper pockets. And I think coupled with this has been a rise in interest rates, which has made access to capital more difficult. I think we have seen that debt markets are improving and there's some inflation management, so it's not all doom and gloom. I think the scale of investment is a question that we are yet to completely solve. We've seen companies like Digital Realty sign joint venture agreements with infra funds such as TPG, GI Partners to raise capital, and we've seen yield co-structures with Vantage to sell off operating and profitable businesses to recycle capital into more greenfield projects. This is kind of tied to those points above, but pre-lets seem to be really important for financial investors that are more picky now and don't want to take as much risk, given that the cost of capital has increased. This is less so the case in Tier 1 markets, where demand is more visible, but in Tier 2 and Tier 3 locations, we're finding that unless you have a signed customer, or at least an LOI, it can be quite challenging to get the finance. So I think we'll see continued investment outside of the south, driven by the lack of power. There's Wales we've spoken about, there's a Scottish flag there as well. Scotland is an interesting market, but it's largely untouched from a hyperscale point of view. And we'll see a continued consolidation of these smaller metro edge facilities. And I think there's going to be increasing demand for London, which is expected to continue to be the leading market in Europe, given its location in Europe, its connectivity, the currency, language. However, there's a question mark about UK infrastructure and the availability of the grid to service that demand. At the beginning, we said it was a fragmented market with 15 to 20 large-scale players. We think there's going to be some winners and losers. The winners are those are the ones that are going to be able to act nimbly and quickly and that have access to capital. And that's it. Next, and maybe I'll hand over to our fellow panelists to introduce themselves, starting with Matt at the end.
Well, very nice to meet you all. My name is Matthew Dooley. I'm a director at DevCap Infrastructure, a European-focused investment firm focusing on digital infrastructure and energy transition, looking to find the sweet spot from an investable perspective of businesses that are transitioning from nascent business models into ones that are more available to core and corporate investors to invest into.
I'm Vincent Gerritsen. I'm heading up the European business for Morrison. We are an infrastructure investment manager, and we're thematics focused. Large part of what we do is digital infrastructure. So we invest all the way from integrated telco, fiber networks, telco towers, and a large part of what we have done is data centers. Over the last 5 years, we've invested north of 10 billion US across the space, with two main investments in data centers. One, where as a more growth value add investor, we typically enter a high growth sector early. So about 10 years ago, we started underwriting a large data center platform called CDC back in Australia. And then subsequent in Europe, and the company name was mentioned earlier, but we are majority shareholder in KO Data, where we started investing about 3 years ago. And for us, taking that same philosophy as being early in data centers more general, we always look for what's the next big thing, what's the next high growth sub-segment within sectors where we are active. Identified HPC AI, where KO, amongst others at that point, already had a contract with NVIDIA housing Cambridge One, so a large supercomputer. So we saw the dynamic kind of developing in that sub-segment, underwrote KO, and we've been successfully growing the business, but happy to talk a bit about that later.
Thank you. Tor Johnson. I'm managing partner of Digital Gravity Infrastructure Partners. We're a specialist digital infrastructure investor focusing on mid-cap equity growth. So we're on the value add segment in the investment world. We look across the value chain. So we've done wireless, fiber investments, both subsea terrestrial and in data centers. Our main focus is data centers, naturally, just given the capital intensity. One of the big platforms for us is sustainability. It is a core to what we do. We are looking for ways. It's a nice intersection when you see power shortages and fulfillment problems because of power. We're big believers that finding creative ways in this space to solve these problems is really the way to do it, and sustainability is one of those.
Thanks. So maybe the first one to Vince. Where do you focus your investment strategy at the moment around data centers?
So just backing into the profile as an investor, more growth value add oriented, it does kind of direct the investment strategy, where overall I think in the data center industry from an investment point of view, there's a huge landscape you can invest in. And you hinted on funding and the capital hungry companies and platforms that are out there. So if you then look at that value add growth end of the spectrum, what I mentioned, the entry point was AI HPC a couple of years ago. That's kind of it's a very demanding use case, and so there we built initial credentials. From there, we with management looked at how can we expand the platform. We brought in financial services, we brought in some next generation hyperscale, but some very high growth hyperscale cloud companies that are there. So I think from that entry point, we are now all about growing and scaling. How can we give more runway in the locations where we are? Number one. How can we provide multiple sites as well to become more relevant for large high growth companies? And one of the examples is Manchester that you mentioned earlier. I didn't know you were born there, otherwise that could have been a reason. But if you look at that ecosystem and the overflow from London, we were connecting the dots. Number one, you've got a good kind of a set of eyeballs, a couple of kind of clusters sector-wise that have local use cases. That won't fill up everything we are developing. So there's a second kind of use case, which is overflow from London. And then number three, AI type use cases. So kind of in our investment case, we think all of the above, and we're having a kind of advanced dialogue with potential clients, both local as well as those AI hyperscale developments. Number three, I think it's the leveling up agenda. If you look at UK, if you look at economic activity, if you look at government support, it's also about where can we work together with government to create economic activity and growth. So that's kind of the interplay.
It's
So
super interesting.
Yes, we try to be one step ahead and provide solutions.
Thank you. And Tor, maybe, where are you seeing investment opportunities at the moment?
Well, you've answered a lot of them right there. Actually, for us, what's interesting is that and one of the themes you take away is that there's an opportunity, clearly, growth, enterprise and cloud growth, but also AI really fueling more growth. But underneath all that, there are some problems brewing, right, with power and fulfillment issues, but also sustainability, right? The largest customers in the space have clearly identified very ambitious targets that they will have to hit, and I think that creates opportunities for problem solvers, and that's what investors are here to do. We're here to solve problems. If it was ultimately very linear in growth, it's not. It's logarithmic. If it was linear in function, it would be the traditional players. But one of the reasons why really three mid cap, small cap investors up here, we're here to solve problems. That's what we do. We align ourselves with the entrepreneurial class, figure out how to be creative about being first to a trend, if you will, or finding creative ways to solve an issue. And I think that's one of the great things about at this point in time in the market. There are problems to be solved, and hopefully our job, certainly as a managing partner, is get enough smart people around me to help solve those problems.
One for you, Matt.
Could I just add to that point, maybe on Edge? I think it's a really interesting topic. I agree with Sigo. I think the Edge thesis will be borne out over the next couple of years. I think obviously it's taken a bit longer to maybe bear fruit, but that's down mostly to the inertia that's been seen in the flat markets, hyperscalers being a bit more wed to the hub model as opposed to a network architecture model. But I think I'm actually plagiarizing someone here in the audience when they said that the Edge is an architecture looking for a use case. And I think what's going to distinguish the operators that are able to succeed in monetizing this theme are those that are able to drive innovation and to really bring the use cases to their customers, as opposed to waiting for the customers to come to them because of their network architecture. So I think that's something that we're going to see get borne out over the next couple of years. You used a really good example, Deep Green. I think they're specialists in being able to reuse heat. That I think is an excellent way to extract all the potential from that this essential data center.
Excellent. And maybe Vincent, what you're seeing is the key investment risks in our sector at the moment.
Yeah, there's a couple of kind of usual suspects if you think about connection and getting power, right? It's a risk, as in it's not available abundantly. A couple of other ones which are, well, not left field, be very relevant if we talk at the board around what do we need to do well. Labor, I think, expertise in the market with growing platforms, different ones. There's a shortage of very experienced people that can run the companies at high quality, deliver on time, run a very smooth operation at high quality levels. So that's been one of the focus items. Sustainability was mentioned. I think I'd add social acceptance to that. If you look at, and I'm Dutch and I won't talk about Netherlands too much, but there was a very large Meta project, 100 megawatts, that had approval, but then the local population kind of opposed to it because it was sucking up all the windmills that they didn't want in their backyard, but that were there. So I think how we embed the data centers and infrastructure in the local communities in a sensible way is going to be key. I think the other one is just for the industry, because we've been with KO focused on what I said, more forward-leaning use cases, sustainability, high-quality operations. But I think and I've had a couple of conversations with larger platforms, the industry is evolving really rapidly. Clients need to increasingly publish in a certain regulation since January this year. They need to publish Scope 3 emissions. What means that if you're sitting or if you're using very old facilities, your contract comes up for renewal, there's a risk, I'll define it very broad, that if you're sitting on old stock in your business, what's going to happen with contract renewals? Can you retrofit? What can you do to kind of make it best in class again? Because I think from the demand side, there will be an increasing focus on those items. So a couple of ideas maybe beyond the kind of the well-known items.
Interesting. Thanks.
I'll just add, and it's related to something Vincent said. Is just that regulation, because of the the perceived problems from lack of power, right? If you start isolating an issue like lack of affordable housing to data centers, who knows, right? That just becomes a whole different hot button. Plus sustainability coming into that. I just think that you've got not just an existing growth of new assets with planning permissions and permitted development, but also with just existing operations. What happens there if you start to have another regulatory framework come back in, or come in? I think those are just some broader concerns. I have financing too. It's a very capital-intensive industry. A gentleman like Chico is an expert on this, so keeps that financing risk out. But you just have, and I would say it's not just debt; it's also equity. You've got some very creative large cap players able to kind of release some equity to continue their growth. That's not that's not so straightforward for a lot of players. And so I think that's just a broader concern.
A lot of interesting points there. I guess linked to that, Thor, how are you seeing kind of M&A pricing and the development of that over the past kind of 18 to 24 months? Have you seen a shift? Have valuations remained robust? Or?
Yeah. In some ways, yes. I mean, I think there is a scarcity problem for high quality portfolios, and so that has kept kind of that core yielding price, I would argue, somewhat up. Dented a bit by the financing costs, but I think overall, and this is really oriented towards more of the growth side. I think you are seeing that the multiples have come down a bit. I think you might argue it's kind of a function of the quality of opportunities have diminished a little bit, but I think undoubtedly this broad rush into digital infrastructure, that I would call it, from the infra community, and I'll leave it at that. I mean, you could argue it's been there with pension funds and some other institutional investors coming from the real estate side for a long time, but the broad rush is definitely, in my opinion, it's obviously there's a lot of demand and it's an interesting sector. It's certainly now seen as a core part of infrastructure, but a lot of people are getting burned, right? So you've got fiber investments in the UK. You can't really talk about digital infrastructure without talking about that. There are people that a lot of funds are going to struggle with that. And that connectivity that they expected is just not. The conversions to fee-paying customers is just not there. Now I'd add to a risk, by the way, going back, is like, people losing money in that space or not having good business plans. You'd say wholesale fiber, you're going to see a little bit of the same. Like ultimately, does that dent the network connectivity that we fundamentally need for this evolving data center landscape, particularly the AI loads, the edge, the other edge cases, like that is requiring much more network. So I worry about that, but that hopefully creates interesting investment opportunities. Again, coming back to the theme of creativity and finding ways to support some of this growth.
And then just building on that topic then, Vincent, what are your kind of predictions for the next 18 months? Obviously we don't have a crystal ball, but if you were to hazard a guess.
Yeah, normally I'm a bad gambler, but no, what I think is for the next 18 months to watch on the financing side. So we had conversations 18 months ago with large parties where they laughed us out of the room when we put our price on the table. But now we're getting calls back because they have, again, very capital hungry businesses. They've committed to contracts. They need the capital. So I think that dynamic will be shifting, and pricing has come down a little bit in the private market side, but that will come down further for platforms that got ahead of their skis in terms of building these great growth platforms, but then you have to follow through, so that becomes tricky. So that's probably the main one. I think will create interesting dynamics in the industry from an investment perspective.
Well, maybe to Matt, so you mentioned that you're focusing on early stage opportunities. How does that fit into the kind of digital infrastructure environment? Because the traditional digital infrastructure investor likes long-term stable contracts, likes to deploy a lot of capital. So how does your niche fit into that?
It's a very good question. I think we kind of see ourselves as a value add player, and obviously there's a lot of different areas within the data center lifecycle to invest in, obviously from very mature to a much more speculative, and I think we would probably find ourselves on the more speculative end. To give you an example of where we see maybe an opportunity in the future, and it's actually going to be born out of where we see risk, is around data sovereignty. So obviously with the adoption of AI and cloud-based AI, that's going to have to transition across borders, and therefore it's going to be very important to understand the regulations across those borders to ensure a reliable service. And interestingly, one of the markets that you didn't have up on your board with Northern Ireland, I think might be a very interesting candidate, where you could potentially develop a platform or develop an operator that has one foot both within the UK but also within the EU, utilising obviously its border with the Republic of Ireland. They're very interesting early stage opportunities there, because it's a very underserved and underdeveloped market, and we're zeroing in on that market because we think there's a lot of themes that we like, and that's great potential.
Specializes mainly in telecoms and technology industries, and we do a lot around growth in those markets and technology, including cloud and data centers and edge. And we have a particular focus in edge, so we've been looking at it for, I think, since 2016, so the 6 years is a bit out of date now, mainly working with, I guess, corporate clients, so the tech companies and the telecoms operators, to understand how we can grow this edge market. And that's a lot of that is informed with primary research. So we're constantly interviewing the end customers, the enterprises, the developers, the application providers. So hopefully bring kind of demand side view into the presentation today. So just to kick off, okay, well, from a kind of investment numbers perspective, we've been trying to track edge computing investments for the last few years. And there's some positive sides. So things slowed down, especially in 2022 with the kind of economic situation that we're in. But we have seen things tick up, and in the last 3 years we've seen kind of $8 billion of investments in edge computing. And this is a lot of it is infrastructure, so data centers, and you'll see some of the big deals from the last 12 months. But it also includes investment into software platforms. So the panel talks about how those types of businesses are key for kind of driving demand and scaling these types of things. And if you put that into comparison with the cloud market, it's about 3% of all cloud investments, of all time. So I guess cloud's been around almost 20 years now. So 3%, it's relatively small, but not too bad, given that edge is still kind of early stage. I think the other positive sign that we've only seen in the last couple of years is more in the venture capital space, but kind of more advanced rounds of funding. So whereas I would say a big proportion of the, let's say, application and platform investments that we were tracking early on, they were kind of angel, Series A, Series B. Those are now shifted to, CD and up. And that's a good sign, A, because it's a sign of maturity, but I think the second thing is I'm going to keep coming back to is it's kind of pushing demand. So it's giving also a more advanced customer base for these edge data centers that are being built. So it's always important to define what the edge is, and I know everyone's got a slightly different definition. This is something we've been working with for a while now. We look, partly maybe because of the telecoms background, but we really think that network is the key differentiator when it comes to edge computing. And we kind of look at the different edges from a network perspective because, basically the number of hops the traffic has to pass through a network has a big determinant on latency. So just to run through these quickly, we do have the device edge. Not going to dwell on it too much today because it's probably outside the scope of what most of us in the room look at. But there is some interesting innovation happening where it comes to end devices and making them look more like an edge compute hardware. And what that means is if you take a video camera, rather than the video camera just having that one purpose of collecting data, it's kind of having the ability to actually swap in and out applications. And that's becoming key in a world where things like computer vision are being used, where AI is being used to enable more interesting inferencing of that data. Then you've got the on-premise edge. That's generally at enterprise premises. Could be a factory running a few servers or an on-prem data center. It could be a shopping center or a traditional enterprise data center. The one that I'll talk about quite a bit today is this idea of the network edge. So these are edge data centers, logically in a mobile network or in a kind of tier 1 fixed network as well. And they look quite similar to regional edge data centers, but often smaller in size and often owned by telecoms operators. And then you have the regional edge, which is, I guess, the final point before you get to the broader, large-scale hyperscale data centers. And this is an evolving space because what, as I think the panel was talking about just now, is what you might deem as a regional edge or a tier 2 city today quickly becomes a so-called let's say mainstream city in the future. So, but generally it's more about the fact that there's a relatively low latency because these are co-located with the internet exchange points. And just to put some more flesh on the bone of these different types of edges, here we've got some metrics we use in terms of power, in terms of how many potential deployments there could be just because of the real estate available. Generally, the network edge, because I'll go into that in more detail, we're looking at up to 250 kilowatts power, and they tend to be up to 20 racks. Most of them could hold more, but that's the level of, I guess, space that the data center owner, who, as I said, is usually a telecoms operator, is reserving for edge computing. One thing I wanted to touch on is the role of hyperscalers in this edge space, because there's a lot of announcements that have been happening in the last few years, and sometimes a bit confusing to marry up what they're doing in cloud with what's happening at edge and the different flavors. And there's been some interesting partnerships between telecoms operators who own those network edge sites and the hyperscalers. And just to touch on the context there and how it's working is essentially the telecoms operators are taking their existing real estate, so central offices where they've housed their networking equipment, and they've been evolving that in their own digital transformation. And what that's entailed is moving from traditional telecoms equipment to more IT-centric platforms and evolving those facilities into data centers, and that's why they are classed as edge data centers. So they've been going through that process, and there's consolidation within that physical premise happening, and so that's literally left space and power capacity left to do more with it and to kind of take advantage of that real estate and provide edge computing services. So where someone like AWS fits in, and there's, in the UK it's Vodafone and BT who've done this, or publicly announced this with AWS. They have a partnership and they work together to bring this AWS wavelength service to the market. And what it essentially means is it gives AWS customers the ability to move applications from the cloud to a telco edge data center like a Vodafone or BT one. And it's using, if you, in terms of the inner workings, it uses the Outpost kind of hardware and software to do that. And then, if you just where that fits in, so you can see there you've got AWS Wavelength, that's the network edge. They also have, AWS local zones, and that for us fits in kind of more in that regional edge space. So we would assume there's slightly higher latency for those zones, because they're they're higher up in the network, but it depends. To be honest, it depends a lot of the time on the country and then the network topology and things like that. And really, the hyperscalers are they are investing in edge, but in general, we're seeing that it's a chance for them to increase their customer base and capture some of that enterprise data center market, and also provide another reason for their customers to move to use their cloud platforms essentially. So it's quite complementary for them. The final thing is just to say, there's a lot of edge data center investment, or there's starting to be a lot of edge data center investment in the UK. You've got Atlas Edge, just heard from Josh, and Enlighten, some big investment there. I think at the moment they're more regional edge. I know Atlas Edge has got the Liberty Global real estate, so it's definitely got some sites in that network edge space, but just to understand where all these different edge data centers fit together. So the thing to highlight is in terms of where the market's at, well, in terms of network edge, it's still, it's telecoms operators, and I don't apologise if there's any in the room, but relatively conservative organisations, and it does take a while. So if you think about, say, BT's edge real estate, they've got, like it says there, 5,500 potential sites. So those are those central offices that they could and have renovated. There's only actually one live network edge data centre that's kind of publicly available at the moment. And if you take the UK as a whole, this is from our kind of network edge data centre forecast. We've estimated there were, let's say there's probably about 5 or 6 network edge data today. That we think that will grow to 18, partly from telecoms operators and some of these new models like the Atlas Edges of the world. But it's relatively slow given the size of the data centers. Is there demand? Well, from speaking to, as I said, enterprises, application developers, we do forecast, this is just for the UK, that there are applications that need this edge data center capability, and I'll kind of highlight some of them in a moment. So we forecast there'll be almost $8 billion of demand for edge computing. It's partly it's low latency. A lot of it is talked about AI in the last panel, kind of data analytics, the need to filter that data closer to the source of the data, so it's more cost effective for the enterprise, the application developer, putting less of the strain on the network, and also offsetting the need to invest in their own data centers at their own premises. So there is that demand. We ran a survey in July last year to kind of really gauge, okay, of those network edge data centers that exist today, what is in them? Is there anything inside them? What are customers using them for? And it was interesting that, if I touch on the left-hand chart first, the applications that were coming up were ones that we kind of predicted in our forecast. So a lot around computer vision and video analytics, and in some ways it's a big bucket, and that's probably why it comes up pretty big, because you've got it in industrial settings and manufacturing and oil and gas. You have not the bit of a scary one, but surveillance type use cases as well, and video analytics, access control. So like if you can imagine in Heathrow when you go in for the passport control and there's like dedicated equipment, the idea is in the long term you could run that compute at an edge data center. So it's those types of applications driving it. And then you have kind of the media-based CDN and video streaming applications. partly because they already have the distributed platforms in place, and so it's a natural next step to go from, let's say, the internet exchange where a lot of these CDNs are running to somewhere deeper in the edge. But there is this kind of chicken and egg cycle, because at the moment there's not much supply, and then those who build up the edge are saying, well, I'm not seeing demand, and then the challenge is the demand side, so the application developers and the enterprises don't have, like, they kind of look and they say, well, if there's one Vodafone edge, what's the point of me developing an application that can only run in one edge data center for only my customers who are on the Vodafone network? So there's this kind of challenge at the moment. I think what's interesting for those on the supply side is, although if you look at the right-hand side, what are customers doing at the edge? Yeah, it's definitely at an early stage. The majority are only deploying in one data center, and it's a fairly limited deployment of a few servers. But the next, if you think about, are they going deeper? So is the next step to put more in that single edge data center or to spread out? It's actually the latter that seems to be more prominent. So most of them are looking to distribute that compute early on. And so it furthers that argument that there needs to be more edge data centers to incentivize growth on the demand side too. So that's the quick snapshot of where we're at. So just to recap, there is this ramp up. I think we're seeing investments in general, although M&A in some ways is relatively slow. We've seen some big deals, and as I said, the venture capital side is maturing on more of the software side. Limited number of network edge data centers in the UK, and that's causing this chicken and egg problem, makes it challenging to incentivize or to see demand. Telcos and hyperscalers are playing a big role, but it's at a relatively slow rate. So it kind of begs the question: do other parties, are there new models that we should be looking for to build out the edge? And need to focus on those key use cases. Whereas in the past, a lot of discussion around autonomous vehicles, drones, things that definitely would need edge but aren't here today, and therefore aren't going to be filling it capacity today. Let's focus on what businesses and consumers need today and build up from there.
Wow, I mean that was a great insight into what is going on, certainly for the UK market. We hear the terms edge thrown about a lot. I was actually quite surprised at how few deployed edge data centres there are in the UK, because the way we speak about it, it sounds like it. And it begs the question what BT are finally going to do with all of those particularly 100 buildings and facilities that actually probably ripe for being sold off to a data centre business that knows what it's doing. We're staying on the edge. We are now moving into AI on the edge with a fireside chat with two industry luminaries. And I'm going to hand it over to Duncan to introduce the session. So, this is the last session before the break, so we'll see you all at the networking break. Over to you, Duncan.
Thank you. So, Duncan Clark, Senior Partner at Cambridge Management Consulting, is speaker. It should be now. Can you hear me? So, Duncan Clark, Senior Partner at Cambridge Management Consulting. I run the data center and edge practice. And when it comes to AI, I don't even know enough to be dangerous and enough to mildly irritating. So luckily, I brought Eric Toff to have a chat about how AI sits at the edge. Eric, why don't you introduce yourself?
Oh yeah, thanks, Duncan. My name is Eric Topham. I'm the CEO and co-founder of a business called Octopipe. We are a federated edge AI infrastructure platform that, as I think we'll just discuss, allows us to solve issues of scale that exist in securely and at low cost training machine learning algorithms on edge devices and then managing their subsequent deployments.
So it's been a very big topic for the last year, I guess. When we were all on team at the same conference last year, I think every single presentation or panel ended up being focused on AI. But people have been very focused on the really massive deployments of big learning systems, hundreds of megawatts of new capacity, which for the industry is incredibly exciting. But there's a lot more to it than that. So, first of all, it would be really good if we could start digging into, why there's a difference between, big learning models and then what actually happens at the edge in real life. And it's very important to realise Eric here developed stuff for proper industrial manufacturing applications. Obviously, there's real world stuff that's happening now.
So, the first thing I think you're quite right. So, my business, we focus on critical systems and critical infrastructure, so energy, mobility, and industrial manufacturing. So, it's an interesting point if I say that AI has a problem of scale. You might not think that because everyone here has been hearing a lot around large language models which have been trained on vast volumes of data freely available on the internet. But the reality is that actually in practical real world physical applications, that data isn't so freely available. These systems are distributed by their very nature. And that means that we have issues that relate to the economics of moving, storing, processing that data in these distributed systems, and problems that relate to kind of the risks involved in data sharing. So when I say that AI has a problem of scale, what I mean is that in the distributed world of edge-based and IoT-based systems and applications, we have a conundrum. You can train algorithms locally on a local edge device, but the challenge here is that generally that device only experiences some small sub-portion of what we call the global distribution, all of the conditions that we might encounter. And so that model learns reasonably well for this kind of small subsection, but when then the world around the device, the physical world around the device changes, or the physical system the device is in degrades over time, that algorithm no longer performs as well as it could, and we observe a loss of performance. The alternative is to take data from many devices, but to train our algorithm at scale in order to learn across a broader distribution that is hopefully more representative of the world and hopefully get better performance. But the challenge here is that that volume of data is pretty vast, and that costs us money to move it on the network, it costs us money to ingest, store it, process it in the cloud. And indeed, even if we can afford it, it may be the case that people are unwilling, for reasons of IP and ownership, personal privacy, and defence and security, to share that data away from where it is originally generated. And so that gives us a problem. So in order to kind of crack this problem of scale, and scale is required for performance, we need a different paradigm, basically, to how we train algorithms at scale. So at Occupied, we have an industrial grade infrastructure that at the heart of it has a piece of technology called federated learning. So in federated learning, what we do is that instead of moving all of our training data off the edge over the network into some centralized data store where we process it, one concatenated data set, we learn a set of global model parameters. Instead, what we do is we create a training program that is going to train the algorithm for a predefined task, predicting the time to failure of a machine. We then send that program of a few megabytes over the network down to the edge computing instances that we want to learn from, and we compute one set of model parameters for this learning task from each of the edge clients from which we wish to learn in the population. Those learned parameters are then returned in a message packet, which is encrypted, over the network back to a central node of aggregation, where an aggregation algorithm, which is computationally extremely cheap, aggregates the contributing parameter values into a global model. So the magic trick we've then just performed is that we've obtained the global model, which has the same model parameter values as we would have obtained by moving that vast volume of data up into the cloud. But the magic trick is I never moved more than a few megabytes of data down to the device to learn, and a few kilobytes of data per device back again. So what that means is that from a cloud compute point of view, it's extremely cheap. It costs us 60 pence an hour, no matter how large the network is to compute the global model parameters. The infrastructure in the cloud is very, very cheap. It costs us £150 a month at scale, doesn't change, fixed cost, doesn't matter how many more clients you add to the network. And just to give you a benchmark, if you consider 1 million homes running a home solar panel system, sampling data once a minute, about 25 megabytes a month, then federated learning is 50 times cheaper in communication overhead than the alternative, which would be to move the data up into the cloud. And that's an exponential improvement if we consider an increase in edge clients, sampling frequency, and feature space, the number of variables that we're collecting for. So once a minute is a really low frequency when actually in a lot of the systems that we're dealing with, we have automation systems where we have sub-second sampling of data because we need that resolution to learn signals at a latency that is useful for the automation system itself. So what this allows us to do is segregate the training process, which firstly means actually that we can preserve privacy at the local device level. We can add noise to the data so the learning program doesn't even actually see the original data. We add encryption. So now we can guarantee privacy across organizations, across individuals, and then we have a really low, really scalable economic cost of training when we then actually perform the federated learning in the aggregation process.
That's a really important development because until recently, models like ChatGPT that everyone's aware of just consume vast amounts of publicly available data. The point about what you're doing is it's using privately available data and then making the results meaningful to lots and lots of different participants without compromising their integrity or their privacy.
Correct. And so there are basically three broad use cases for this kind of federated infrastructure. One is that you are a single entity but maybe has sub-entities where there may be jurisdictional reasons for not moving data between them, or you don't want to run kind of IP risk even within an organisation, but say across geographical boundaries. But generally, also really what you want to do is just leverage the kind of efficiency benefit of this distributed compute capability. The second one is that you are an original equipment manufacturer of a connected, intelligent product. Robotics is a classic example where you need to improve the performance of your algorithms to enable the complex tasks that your intelligent product is going to do. But unfortunately, the data that allows you to train your algorithm well enough only exists at a scale present if you can train across customers, in short. So you need to be able to preserve the privacy and ownership of customer data. And the third is a collaborative setting where you may get a group of blue chip companies that are normally competitive, and that you may have a non-competitive use case for. Health and safety is a classic one. So I want to reduce health and safety incidents in my warehouses. I might be P&G and I might be Unilever, and I might have this aligned use case. I would like to solve that problem collaboratively, but not at the risk of sharing data directly with each other. So with federated learning, we can install local edge servers, edge PCs, into the warehouse, connect them to CCTV systems, connect them to existing computer vision systems that collect metadata on the occurrence of these events, and then in a privacy-preserving way we can train algorithms, for instance, to estimate the likelihood of these events happening in some forward-looking window in real time. We can aggregate the models across organisations. And that's particularly important where we're trying to learn either quite complex signals that need scale or rare events, so things that don't happen often. We need a larger observation space to see enough of them. So we can get this scale by guaranteeing privacy and lowering the cost of learning.
So, I mean, that again, really interesting because I think this is how we're going to see technologies like AI break out of just the really big boys who can afford to deploy massive amounts of capacity into the wider world. There was an interesting, I think it's been up a couple of times, that the idea that 80% of the data centres at the moment in the UK are in London, Slough. 80% of the economic activity in Britain is not in Slough or Docklands. I think that look one says something like 8% of the data centres in the UK are in the north and the Midlands. That's where the vast amount of manufacturing and industrial processing goes on. So for me, this is looking at a way of actually enabling the deployment of edge into commercial applications, which are going to require a proper distributed platform, which has been a reoccurring thing throughout this. So now you're a relatively young company. You've just gone for another round of funding. Congratulations on that. How are you seeing the market opening up to this type of technology?
Well, I think it's really interesting. In the last week, we've been approached by two different Horizon projects, both of which looking to build slightly different versions of collaborative platforms for collaborative manufacturing or collaborative applications in smart infrastructure and so forth. So there definitely is use case that is bubbling out, not just in kind of the RTO world, but also in industry. We definitely see places where, like robotics, frankly, the industry has an issue of scaling itself commercially, and that really comes down to issues with the core functionality and the performance of the models and so forth. Even for relatively simple things like pallet identification for picking in warehouses, the models are relatively febrile, and there's a lot of upfront cost to get those systems configured and deployed. If we can bring that cost of, on the one hand, learning and experimentation down, and then by extension, by having better models, we can bring down the configuration and deployment costs, the upfront investment by the client, then that industry, for instance, has a chance of scaling. I think the other thing that's interesting is that these systems live in the physical world. We have heterogeneity. We have natural clusters that exist within these systems. And federated learning really allows us to kind of leverage that to our advantage. We often get asked, but all of my machines are a little bit different. How is your global model going to generalize here? But in fact, we can leverage this by grouping machines. We can take partial aggregates that are effectively a trade-off between overfitting locally and global generalism. And indeed, we can take base models and fine-tune them down. So an idea that I think is pretty cool in robotics is the idea that for smaller, more innovative businesses but don't necessarily have the funding available to invest into acquiring data sets and so forth, perhaps they can train base models collaboratively to learn base representations in the manifolds, but then take the base model and in each of their verticals fine-tune it through things like transfer learning to their particular application. And so, I think it really kind of opens up the economics of learning is really what we can do, and we can leverage the topologies to get those performance.
It's absolutely brilliant. For me, my particular personal heresy is I come from IT, so I always think about the application. It's not necessarily the most popular way of looking at things in the data center industry, but this is actually what's going to drive change and growth, I think. In all the sort of commercial markets for the next several years. Is that something that you're gunning for?
Yeah, I think we're pretty lucky. We are one of only a very small number of companies addressing federated learning globally anyway. At this point, we're early. We're effectively a deep tech company trying to kind of accelerate bringing that technology out. Federated learning has been around since 2017. There are some good reasons why it hasn't been widely adopted before now, but largely to do with the fact that unlike the cloud, there isn't an existing infrastructure stack for then the rest of the ecosystem to build on. If you think about the development process, while we have the way of doing the learning part, it's the upstream parts of the process going from data labeling down that have yet to kind of catch up in this distributed setting. And so actually a lot of our product focus at the moment is focusing on enabling these parts of the upstream process. Scale then comes later. So I don't know if that answered the question.
No, I think, and for us to understand, this is what's going to unlock demand and help build the business case for investment in edge infrastructure, because you need all of it. And the thing I've been learning over the last few months, is there are so many different types of AI applications.
But the interesting thing is that in the kind of distributed edge and IoT space, there are a lot of use cases that are not being undertaken, or if they are being undertaken, they're being left at the POC stage because at scale, economically, they become unviable and they don't even get addressed sometimes because of the data access issue. So really what it's about is for us is I guess getting off the brakes of the data flywheel, opening up access to data and lowering the cost of learning. That brings performance, and then people can really come and take off from there.
There's one use case I should just mention. It was in an industrial manufacturing plant in the West Midlands, who used techniques like this to improve production line efficiency. They got a 1.5% improvement. Doesn't sound much. It's worth hundreds of millions. So this is big stuff. It's going to affect our industry for the next several years.
I mean, we have in manufacturing, there's a big thing around servitization. So we have a customer, OEM of a metal pressing machine to make aluminium cans, very high volume process. The end goal is to have a model that can in real time estimate the likelihood of a stoppage of one of these machines, because it's such high volume, low margin, time is money, literally. And so the models that we can train have a pretty high impact on additional, we're talking like millions of additional cans per canning plant a year. But the challenge they have is the IP around canning with is very sensitive. So the only thing that allows them to develop this servitized business model is the fact that they can preserve privacy of data across their end customers. But actually the bit that's really interesting is that having solved that piece, the bit that their eyes were kind of sort of open to is when you showed them the ROI calculations on this and you compare at a gross profit level, the profitability of the product with a cloud-based infrastructure versus a federated infrastructure. The cloud-based infrastructure is 5 times less profitable than a total gross profit than the federated alternative.
And that will resonate really well in this room. So look, I think we've run out of time. Eric, every time I talk to you, I learn loads and loads more. It's absolute joy to have you up on stage, teaching us about why we actually build data centers. This is what it's all about. So thank you very much.
Duncan, don't ever apologise for being involved in the IT side. If 15, 20 years ago we'd actually taken note of the IT load and spoke to software engineers, we might not have had to unpick things within the data centre. Again, another fantastic presentation.
I joined Yonder about 3 years ago as global CIO, where I set up sustainability. I left Yonder a year ago, and I now work for carbon net neutral tech solutions. We do carbon baselining. We work for the likes of Dell and Mighty Group on the enterprise there. And a lot of the things that we're recommending to clients now will impact the industry. I've got sort of probably a unique position in that I work for a data center provider and understand the challenges around cost control, but also the end client and what they're looking for in the future in the context of emissions management.
Hello everyone, thank you for having me. I'm actually not from here. I live and work out from the Bay Area, Silicon Valley. How many of you have been to the Silicon Valley? This is actually very curious. Question I always have. You've actually been to a place that has no latitude and longitude gradient. Silicon Valley is actually more a metaverse. It's a name that you all given to us because the fact that we are just kicking ass in innovation. And we also have stories about turning around CEOs and founder. You probably know that story. But anyway, it's a pleasure to be here. Really glad to be here. I have been in a data center for going on 33 years. Started as a computer scientist. My actually second program is natural language processing, which is one of the AI technology that I was actually fascinated in. And now actually, I would say Meta announced 101 language in a multi-domain and a multi-model by being able to translate text to video. I think this is just amazing. I would never imagine actually that happened in my Earth time. Absolutely a privilege to be here because I love sustainability. I'm extremely passionate about it. Before I go forward, can I get the ladies to stand up in this room? Actually, I counted. It's less than 26. Please, take a stand. Join me in giving us a round of applause. You cannot start with ESG without embracing inclusivity of talent and diverse talent. That is actually one of the initiatives. So please, I beg you all, especially the male, if you actually go to the next conference, please bring a lady colleague. Or better yet, actually have an investing partner who is actually a lady. Okay, so that's my plea. I've done 3.8 gigawatt of clean energy projects I specifically focus on hyperscale. So clients include Google, Microsoft, AWS, Meta. As a data center advisor for the UN Sustainable Development Goal Program, I run around and back. I run around and listen. I run around and actually create an impact program. So you all have read about it in terms of these carbon neutral or carbon negative pledges. Sadly for me to tell you, only 17% of all the companies making these pledges actually have a written plan how they're actually going to reach the goal, regardless actually where the decade is going to be it 20, 40, 35, 40, 60. And I said, please do not talk to me about 2050 or 2060 because my Earth life will probably expire. But I'd like to actually see you taking action. So very excited to be here today, leading more. For anyone who wants to know more about my work, I'm actually a real geek. You heard about the net zero. We've done the 4 pillars, obviously the just transition for energy. Lauren and I talked a little bit about water, which was actually exciting, we'll answer that. The other one is actually emission. Given what we learned from COP, very disappointing because they let the clowns in on day 3. But the good news is the fossil fuel, they decided they're gonna exit. So in addition to actually all your investment, which I thank you all for doing what you do, the dollar that you basically put in, I beg you all, please take action and making sure you ask the people you give the money to or your partners, how are you gonna measure it? If you don't have a goal, if you have a goal, you can measure it and you can come back and you pivot yourself. And if your line is actually straight, then you're doing something freaking wrong. I guarantee you that. Okay, so very exciting, and the next thing I'm actually launching, well actually not next thing now because I have no idea how January gone by so fast in 2024. I'm driving absolute zero with the Hyperscaler. So stay tuned, we can talk more about that online and whatnot. And absolute zero would decide the whole design, how we actually construct the build, including the material, but more importantly about the location, the site, which I think there was a lot of talk this morning. But more importantly is actually the decommission, because we really want to regenerate the waste. So we designed the next generation AI data center with absolute zero, knowing how we're actually going to decommission first before we allow anything to be built. So those are some of the concepts that we have. And you next.
My name is Lauren Long, and I live outside of London, as you can tell by my voice. Laughter.
I was going to make the pledge to them that you had promised not to do any humor, but since you got a laugh, I can't make that to them anymore.
My background is in telecom and technology. I co-founded one of the early edge data center companies in 2012, which was then acquired in 2020. And since then, I have pivoted and focused everything in my engineering background and strategy into sustainability. And I'm now a co-founder in another company called 3Tag, which is developing a platform to digitally tag and follow the embodied carbon and circularity information of equipment at the component level, building up to an aggregate to increase granularity, transparency, and governance from cradle to end of life to support circularity.
Well, I have one piece of really good news. When this panel is over, you guys are an hour and 20 minutes from having cocktails. So all you have to do is get through 30 minutes, and then you guys got one or two more panels, and then cocktails out in the back. So the first question I'm going to ask is to Susanna. As part of its plan to reach the goals set out in the Paris Agreement, the UK government has set a target of reducing all carbon emissions by 68% by 2030. Bringing increased focus on ESG and overall best practice and sustainability across all industries as pressure intensifies from investors, customers, and the public, our data centers are starting to face increased scrutiny, regulations, transparency of their operations. Do you think the data center industry is doing enough to meet these fast-moving targets? Are they moving fast enough to meet all these targets?
Okay, so I'm a little bit biased because we actually have a prep meeting and we actually had a very healthy debate. From an evidence perspective, most recent evidence, go back and take a look at COP28. held in UAE, for crying out loud. What do you expect? The truth came out. The clowns come in and they say, hey, I don't think we are hurting the industry by using fossil fuel. We can't shut it down because then we stop civilization and we stop industrialization. Well, the word civilization and industrialization is actually how people decided to just bulldoze a bridge, a road in nature. We need to invert the status quo when we're truly thinking about sustainability. And think about one thing, and I hope I'm not insulting any of you all. I'll start with myself. When you think about sustainability, what problem are you trying to solve? I got stunned at a youth summit at UN when they say, oh, okay, we don't really kind of understand data centers, Susanna. And they're all youth, right, by the UN. How do you measure sustainability for what you all do, adults do, in 50 years? Do any of you even think about what life is going to be in 50 years? You full of shit. I don't think you do. I don't think you do. Okay, I genuinely call you on it because I love the young generation. I sit on a board on many young talent and I mentor 900 STEMs, 89% of them are girls. You would assume that I actually dedicated my time on doing that and talk to Lauren about it. A few of them actually sold their company. I'm actually really proud they go through the whole thing. His daughter, you have to tell the story, basically just inherently have the natural instinct to do the right thing. And may they not call it sustainability. Okay, so does the UK government do it enough? Louise is totally correct. She corrected me in terms of my perception. Instead of just looking at the global number for data center, you gotta just like perk up and look around you. And you'll be able to kind of see it. I see the city is full of non-green concrete and non-green steel. It's a concrete jungle. It's the, compared to the new places I'm seeing in Japan and Korea, you know we're actually building data center you can't even find. Other than the fact that you get renewable energy, we're giving you free water, we're giving you free heat because of district heating and cooling, and at the same time, we're doing something I absolutely admire. There's a LinkedIn post that just got posted last evening by my very good friend at Microsoft. We're absolutely doing gigaton capture. Instead of like complaining or talking about things, we decided the data center after COP, we need to not give up and work harder. Not only we need to do the just energy transition and be able to make that impact, but at the same time, we also need to do the carbon capture. You know, fossil fuel is actually not evil. It's not. It's the emission that comes out from the fossil fuel versus the emission comes out the renewable energy is what we wanted to negate, correct? And I'm not talking about accounting offset. We're talking about the on-prem. So does UK do it enough? I think I can kind of say that because your prime minister is actually very famous on my campus because he is a Stanford alum, so is his wife. So Stanford all of a sudden got into it and said, oh, we're training future government leader because he's the only one, the first one. Hopefully we have more. From an impact perspective, listen to Louise. When she talks, we should listen because she is one of the ladies who actually are hands-on building it from the ground up. She sees the good, bad, or the indifferent about how sausage is actually being made is actually how we Americans say that. I actually only look at that from the carbon neutral pledge perspective by the data center and hyperscaler, and to that I have to leave a very positive note. For the 3.8 gigawatt and the 7.8 that we actually have done for the renewable energy, we are totally capturing the emission and the target. So yes, I think the data center sector is leading. If nothing else, we're the pioneer of leading that compared to other sectors like manufacturing or even life sciences and healthcare. But we need to all embrace that. And I have to say that I meet a couple of folks here. I'll do a shout out for one of the partners that basically got on stage with the first panel, Digital Gravity partner. Okay, they start the fun in terms of thinking sustainability and zero emission first. And I thought that is so amazing. in that regard, because you really put it as your mission statement to be ethically responsible. So this is encouraging. As much as I like to talk about Sand Hill Road and whatnot, but I believe the right mind and the center of investment is actually here. Because I put in the post regarding this, 1.8 billion is actually done by Microsoft declaring we want to train the people in the AI. And then 3.8 billion by AWS is actually to strengthen the digital infrastructure. And I hope they will hire Louise to basically help on establishing the baseline, especially the baseline, and then help to actually achieve the carbon neutrality. So that's my wish, but let's listen to the expert in terms of what her answer is.
Thanks, Julia. Oh my God, I need to hear more about that. So I think we're seeing pockets of sustainability initiatives, if I'm honest, mainly driven by planning or investor requirements. It's not widespread. The fundamental designs of data centers haven't really changed. They're still driven by SLAs. You've got this interesting problem really where you've got clients asking for reduced emissions but not wanting to change the architecture or how the data center operates or the availability of services. When actually you can, if you look holistically across the IT stack now, you can move workloads across the globe depending on where you've got best renewable energy supply or where conversely we've got really high fossil fuel content and fuel mix. You can be really sophisticated now, and clients are moving in that direction. The problem, as I see it at the moment, because we've got this sort of pocketed approach really to sustainability, and I think that it's not just the UK, it's everywhere. Everyone sort of does least minimums that they can get away with. You've got, from the client side, you can't create consistent processes. So we were doing some work for one of the hyperscalers, and they were looking to be able to move workloads across the globe depending on what's happening in the specific region from a compute density perspective, or the fact that they had higher renewables in this location. But they wanted to be able to smooth out compute from a region, so a city, a region, and a country level. But they couldn't get the data from different data center providers, and it was predominantly the colo providers couldn't provide really good quality, lower level emissions data based on consumption at server level. And you could argue that's client responsibility, they design their own racks, they design their own halls, but actually the data center providers themselves need to have that infrastructure in place. You need to have sensors to be able to provide really good quality humidity and cooling detail. You've also got to have the right BMS environment and the right networks really internally to be able to give clients real-time data on electrical consumption. So I think there is like a big gulf in what actually clients are needing to move forward and to be able to manage their own emissions up and down the stack, and how the data center industry really is kind of almost staying put. And actually, if you can offer lower SLAs, you effectively lower the engineering on the side, which means you lower cost. And you can spin them up as eco options. You can do lots of interesting things with sustainable options. It doesn't need to be a binary yield discussion. In fact, actually, if you're talking to hyperscalers, you'll have an advantage from providing a lot more data and a lot more sustainable practices on site. And that's just not in the operation. And I think the other problem we're seeing actually is the PPA get out clause, which is I've signed a PPA, I've got zero emissions. No, that's not correct. Actually, the way we track emissions now is location based. We're not looking at it purely. I've got PPA. I'm writing on my. I've got zero emissions from on a scope 2 perspective. Where that data center is, what access it has to renewables on a 24/7 basis is tracked, and that does count towards the emissions count. So AWS in particular need a little bit of a slap. I don't know if there's anybody from AWS here. So in short, there's a lot more to do, but there's a sort of couple of messages that we say to clients when we go in. If you're thinking about sustainability, just think about in terms of these principles. Design for the service. We've heard lots of top conversations today about AI and how the different designs that's affecting the design of the data center and cooling infrastructure. Think about efficiency in cooling when you're doing that design, and make it as modular as possible. Consume less. That's consume less when you're building, consume less when you're operating. Optimize the assets, optimize your estate, and then shut down when it's not in use. These are all basic sustainability principles for carbon emissions. Sorry, that's about this one, 3 minutes each, isn't it?
Next question.
Were you wanting to add something more? Okay.
No.
Well, I'll give you. What is the future for legacy facilities?
So like, what does it mean for it? So I'm gonna assume legacy means pre-existing, let's call it 10 years old, maybe?
No, done, design done by white male.
So I think there's threats and opportunities. Obviously with the EED, you know, there's gonna be pressure. You know, are there grandfather clauses? Yes, there are. Does that save your customers, or does it help them in their competitiveness for their sustainability goals? No, it doesn't. So there's going to be that pressure. But I also, the opportunity that you have is that sustainability is actually a really big, it's a huge topic. Climate change or carbon is only one of 9 planetary boundaries, one of only 17 sustainable development goals. So broaden the scope. You know, if you look at embodied carbon of the built environment, your data center's been there, it's done. So help change the topic or the discussion around scope 3 and how we calculate it against newer builds. I think another, obviously upgrading the infrastructure to be more efficient, but I think the other thing that I would not do, and I'll end with this, is don't do easy solutions like offsets. Those aren't going to be around for much longer. And like Louise said, PPAs, hopefully those aren't either. So don't just follow along with, if it's easy, it's probably not going to work that long. What do you think?
I like it. I mean, I'm supposed to say it. Sarah, hit me again with a question, please.
What is the future of legacy facilities? I'm not thinking it's going to be so positive, since most of them may have been built by old white guys. So,
no, actually, I do want to credit. I thank everyone in the industry who are predominantly dominated by male. We all know that. I'm not trying to make fun of it. It's a fact, right? Okay. And without it, actually, we wouldn't be where we are today in terms of the internet connectivity, accessibility. Given said that, we are in the next era. AI just disrupted it, right? Okay, so I do cheer for it. I'm actually getting a couple of sponsors, and hopefully my dream will come true before I expire my Earth life. Is we're completely doing the entire next gen AI data center with women. From the design, the operation, the build, the construction, and more importantly, we're actually good about breaking things. So we actually work on decommissioning design before we actually start building. And the location we actually already chose is actually in Copenhagen. So we shall see. And then the other one we're looking at is actually in Japan, which will speak a cultural segment for that country. What is the future of data for the legacy data center? I'm actually more a computer science and a metric scale, okay? So number one, the metrics gotta be different in terms of the next gen of how we actually do the upgrade for the legacy data center, okay? So instead of looking at it from all the 9s, how many of you heard about all the 9s that we basically use? 7 9s, 9 9s? The work that actually done by the previous successor that I've learned a lot is actually less than 2 seconds of downtime allowed. So pause for a second, have all the respect for all the old white male dedicated their entire life managing 0 downtime performance. tremendous respect for that. It's essential, but the future of that data center is insufficient. Just managing that itself is insufficient, in my opinion. We need to actually do things more sustainable going forward. We also need to care about the people, the planet, and like this gentleman, the only one who actually said he think about it, and I'm actually want to have a chat with you. Like, what do you think about 50 years from now?
So you think about your kids and their grandkids. I've also worked with a lot of Nordic companies, and they have a generational view. So I was a member of the board of Green Mountain for 5+ years. So I knew the Smedvik family well. And when they invest in digital infrastructure, they were investing generationally. So that 50-year time span for them was very much in their mind. Yes, they sold up at the right time, but their legacy still lives on. And I believe you spent a little bit of time with that company too, so you would understand their thinking. I also worked with...
Except that they invite me to ice fishing. I said, no, I'm not. So thank you for actually sharing that. We should print that. I think this will be great. So the future of legacy data center is very encouraging in that regard. However, we do need to think differently, and we thank the previous generation of getting where we are today. We wouldn't be where we are today, so we need to say thanks and be grateful. But just continue that route, in my opinion, is essential but insufficient. That's why you're all here. Who cares about what we actually did in the last 50 years or the legacy debt? It's basically we don't have to start from scratch. However, we do actually need to build things differently from what you basically said. Is that okay, Sarah?
Sounds great. So I think we have time for one more question, and I'm going to direct it to Luis and Lauren, and you guys have like 1 minute. Okay, 1 minute tops. So in a recent podcast, Andy Lawrence with the Uptime Institute said that there is a sustainability reckoning coming. And he said that executives have a huge disconnect from what the world actually wants. And my question is, are operators and enterprises prepared for the impending legislation on more complex Scope 3 emissions reporting? Luis, you go first. And I'm timing you.
Okay. Scope 3, massive misdemeanor, right? People don't understand what it is. Scope 3 are the carbon emissions associated with the service that you're either receiving or you're giving, right? So if I'm a data center provider and I'm producing a Scope 3 statement, that needs to include the software I use on BMS, the emissions for the support desk, so if somebody calls up. It needs to include everything associated with the service proportionate to what is being sold. It is not, here's my electrical bill, here's the electrical bill, and I've offset it with some kind of newfangled offsetting rule. Scope 3 is calculating the emissions that in a detailed fashion against the service that's being provided or what you're purchasing.
Okay.
So, do I think people do it properly? No, we've just done some work with a client where we researched 100, virtually, well, it was 110
Okay, you said that's
suppliers.
enough, everyone.
86% of them came back and did it.
Yeah, Norco, she only gave me a second.
I'll be super fast, and actually I'm going to talk to our host and the other attorneys in the room. I think the next 36 months is going to be really great for you guys, assuming that you prepare for what's coming. So I'm going to bounce off her answer. Scope 3 is complete Wild West on so many levels, multi-dimensionally, and I'll be happy to tell you about it. But anyone who says they've got Scope 3, no, they don't.
Yes, do you? No, I will argue that. I have a fact. Go
Okay.
on.
You will be.
Can I argue that? Okay. The Cupertino, hang on. The Cupertino company that come up with the wash that many of you guys have on your risk has complete transparency accountability for spending $4.5 billion 8 years ago to ensure their product is net zero.
Okay, I'm not saying the company's.
So there is this company.
Okay.
Okay, Lauren, you have 30 seconds.
30 seconds before I get
Okay, here's the thing. We're entering an age where attestations are going to become very important. The greenwashing law that was just passed, that's going to come into effect in 24 months completely denies the use of offsets. So what happens through the supply chain when the biggest vendor who's selling to Microsoft now has to roll back their claims, and now the claims, and who's gonna pay for that? California's got penalties. So my answer is, wow, here it comes.
The stick, yeah.
Yeah.
Yeah. Thank you, Sarah.
Huge thanks to Sarah and to the panellists. And in this topic, you know, there are entire conferences going on for days and days. They're trying to put it all down into one session. I think they've done a great job in covering some of the really important points. Now, sustainability obviously is a huge, you know, from the ground up, it's not just about the traditional power that we thought about. But of course, not just from sustainability, we are running out of power in London, as we've heard already. So segueing nicely into our next session, which is about the state of the UK grid. And we can't underestimate the importance of what's going on with that UK grid in terms of what we've been talking about from the operator and investor perspective already this morning. So if I could invite Paul Manning from Nova Grid up onto the stage. Thank you, Paul.
I submitted these slides very late last night. The reason for that was a conversation I had actually with an existing customer of mine, who for me is probably one of the most intelligent renewable energy developers in the UK. And I didn't realise that she'd started her career in the 90s developing data centres for BT. So I asked her, you know, I've got this presentation about the power grid to a lot of people from the data centre industry. Where do I start? I had a presentation. She basically said to me, she's like, Paul, you have to think of it like, basically data center people are mostly telecoms and finance backgrounds, used to playing football, who've now wandered onto a rugby pitch. That is the power game, and we don't know the rules. So with that in mind, my name is Paul Manning, and I'd just like to say, welcome to the power game. So, hopefully that's it already. So my name is Paul Manning. I'm the co-CEO and founder of Nova Grid. We are a market-leading grid analytics software company based in Dublin, but we work all over, predominantly in the UK. And what we have is a grid analytics technology that's able to model the power grid, and we're able to leverage the outputs of that software in order to provide what we call actionable insights. So that can range from power trading, real-time data, control software for wind farms and solar parks. But what we're going to talk about today is being able to analyze the grid to find grid connections we do it for a lot of the big renewable energy companies like EDF, etc. But also we can do that, and we are increasingly doing that for data centers. So, how to play the game? First thing is the objective of the game is to connect sellable capacity faster than the other players. Now I say sellable capacity because you're not going to connect a data center up in John O'Groats, where there is plenty of power capacity. If anybody is feeling frisky, you can go up there. But to connect sellable capacity faster than the other players, okay? Now, faster, keep that word in mind because it's all about speed. How we play is via the queue, okay? You gain that capacity by applying for and accepting a position in the connection queue. Okay, and it's very, very important that you understand that it is a queue. And it doesn't matter whether you're Jeff Bezos, whether you're Larry and Sergey from Google, or whether you're Mrs. Murphy from down the road who wants to connect a solar park on a bit of land that she has. It's the same queue, and everybody's got to get in line, okay? So this is just the way it is. You can get frustrated at the utilities, you can roar and shout at them, and all they'll do is just go, next. That's it. Okay? Your position in the queue matters, and the only advantage that you have over the other players to get into the queue in the right position is speed. Now, you need capacity. So the capacity today has limits on the grid. Okay? There is only so much power a circuit or a transformer can take. It's called its rating. Okay? It just can't take more than that. It can be expanded infinitely. We can build as much capacity as you want to apply for, but that takes time. It's incredibly slow. So the reason most of you are getting delays in your grid connections is because you are applying for more megawatts than the existing capacity there is today. Therefore, the grid must be expanded to meet your capacity, and that takes time. I'll get into a little bit later exactly why it's going to be slow. Now, one of the other key bits on this one is where you play and how the grid is divided up. And it's divided up into voltage, okay? From the very top, 400 kilovolts, that is the big, massive power lines that you see running down the spine of the UK, down to 11 kilovolts at the bottom. The transmission network, which is in the UK, National Grid, is 275 to 400 kV. That's what they manage and control. And then the distribution networks, in the US call them sub-transmission, is anywhere from 132 down to 11. That's your UK power networks, your Electricity Northwest, SSEs, those kind of people. Okay, this is who you're applying into at those particular levels. Now, typically you can connect in 100 plus at 275 up, and then 132. That's actually where the majority of you guys are going. So you're actually mostly applying into the distribution system, not necessarily the transmission system, and that comes with different timelines, different amounts of money that you have to put up front, different capacity. And critically, notice it's not 50, it's 49.9, and it's not 240, it's 39.9. And the reason for that, they're transformer sizes. Okay, so don't apply for 50 because you're going to cause a transformer upgrade. Apply for 49.9. And if you want to go lower, and we talked about at the stage, and Josh, you know, those guys were here earlier. If you're going in at that kind of 4 megawatt size, go for 4.99 and apply in at 11 kV. It's much easier to get in that. Okay, and if you want to go for 4.99s to get a 9.98, you'll get 10 megawatts in and apply the 11 kV network. That's where you want to play it. Okay. Now, you're not alone in this game. Trust me, you really are not alone in this game. There are other players. Obviously, generators, the fossil fuels, but more increasingly, the wind and particularly solar. Solar is the single cheapest form of generation that exists now in the world. And it is getting rolled out at eye-watering speeds, okay? You were up against these guys for that connection queue. Okay, you're thinking, well, hang on, these guys are exporting power out of the grid, and I'm a demand connection importing power. And it's like, yeah, but it's still a network design engineer has to run your application, and that takes time. And if you're in behind the generator, it's going to take them time to process your application. You're up against other demand connections. Housing, we've talked about it in terms of the ESG goals and how we appear to the public. Okay, you're up against all those housing estates. They have to apply for demand connections as well. They import power from the grid. You're up against each other. Unsurprisingly, that one. You're also up against electric vehicles coming out more and more en masse. They're also putting power in off the grid. Okay, so they are applying for that same demand capacity that you are. Slightly less, but equally can be particularly large in certain areas. Hydrogen electrolyzers. Okay. These are going to tend to be big, larger demand connections. We're seeing, we did about 3 of them this month already, or January just gone, across the UK. And they're also coming in at the kind of sizes of anywhere from kind of 20 to, I think the largest one we had was 350 megawatts. That's the same grid connections that you guys are applying for. So they are direct competitors for you in the grid connection game. But number one, and I cannot stress this enough, your number one competitor for grid connections is energy storage. All right? I picked this rather pixely picture for a very good reason. Each one of these shipping containers is 2.5 megawatts of demand. Okay? That's them pulling energy in off the grid in exactly the same way that your racks are pulling energy in off the grid. From a network planning and design engineer's point of view, there's no bloody difference between the two of you. Okay? It's the same grid capacity. And if you count them, there's 16, and trust me, there's another 4. So that's a 50 megawatt demand connection in an urban environment. And we have one of the largest real estate investment managers who came to us with a whole rake of former cinema car parks. And all we did for them was connect these in. And these are in prime areas where you guys could have connected in data centers, but they went in ahead and installed energy storage and took that same grid capacity that is now not going to data centers. Now, just to give you a sense of the scope and the scale here, in the UK, there's just over 2,000 megawatts, 2 gigawatts of energy storage utility scale installed today. UK data centres, that's probably just the London figures for yourselves, might be a bit more for the rest of the UK. But already they're near, they're twice as large as you in terms of megawatt figures. But by 2030, there are 25,000 megawatts of grid connected batteries going to be installed in the UK. And I know this because Novogrid has done 3,500 megawatts in 2023, just in Great Britain, just with energy storage. Okay? The numbers are off the charts. This is your number one competitor of the energy storage guys. Okay? You're only going to go 2.5x, they're going to go 12x. Why data centers lose? Okay? And I'll be nice. Well, I just told you, it's storage developers. We have one of the major storage developers in the country, and they're making 2 applications a week. Okay? For the same demand connections that you guys are applying for. You're overly concentrated. This is your other problem. Get out of Slough. You guys think of Slough, you think of West London, you think of these large geographic areas. I don't. I think of Ibra, I think of the 4 transformers, I think of the 2 cables. I literally think you've all squashed yourself into an area this size, right? And you're wondering why the grid connections are taking so long, because you're squashed into a tiny concentrated area. Get out of London. There is plenty of other substations. This is a what we call Grid Atlas. It's a tool we've used. It shows every single substation over 132 kilovolts in the UK. Gridatlas.novogrid.com, you can get access to it. And if the capacity is available in them, you can see where the substations are, where the people are, obviously. And you can see what's available in individual substations and transformers. There is plenty of capacity available in Great Britain if you know where to look, and it's not in Slough. Now, this is one I spoke to Warwick about last, I think we were in RT, and he couldn't believe it, so I had to include it, okay? Ready, steady, goes. And GOES stands for Grain-Oriented Electrical Steel. And trust me, you did not expect to have to hear these words there. Basically, it's very, very high-end, high-quality steel that forms the heart of an electrical transformer. It is produced in very few factories around the world. In fact, in America, the Department of Defense actually had to buy one of the factories to ensure that it stayed open for national strategic reasons. It is what is causing so much of your delays. And the reason for that is to build a transformer, it has to be built by hand. So if you look at this guy here, he is winding copper wires in a wooden frame around the core of that grain electrical steel. Okay, I'm going to play a little video for you like we're in school here. I don't know if you can see the captions, but they really do matter. This is the Siemens transformer factory in Nuremberg. All of these people are winding the copper around that grain-oriented steel in the core by hand. It takes 7 years to train as a winder. They're paid 6 figures. It takes 4,000 hours to build one transformer. Okay, and every time you go and trigger these capacity upgrades, every one of these has to get ordered. Please don't wonder why it takes so long anymore, because this is the reason. This is Siemens, by the way. They've tried to automate this process and they can't. It is a highly skilled, highly manual process where every single transformer in the world is made to a bespoke solution. So one of the things when we go back to that capacity is find out what capacity exists today so that you stop triggering a transformer upgrade and then delaying your ability to connect. So if there is only 38 megawatts available on the network, don't apply for 40 because you'll trigger this. Whereas if you apply for 37, you get your connection in a couple of years, 1 or 2 years as opposed to 5 to 15. Particularly for the very large ones, the 400 kilowatt ones. So we talk about all these big 500 megawatt, 1,000 megawatt campuses. I really and truly hope that they have patience to wait for those 400 kilowatt transformers to be built, because it's only the likes of GE, Siemens, ABB, Hitachi who can build them, and you're already in a queue behind EDF, behind Iberdrola, behind these other massive companies who know what they're doing in the power game and have already ordered these, oftentimes 10 to 12 years ahead of time. So, what I would say is one of the critical things, and I was talking to Kate, and she said a bunch of telecoms people and finance people who are playing in the power game now is you've got to build a power team. And when we talk to data center companies and they say we have an electrical engineer who's able to do this, but I say to them, but do you have the exact type of electrical engineer? So obviously you need an electrical engineer, but do you have a power systems or a network planning engineer? And that's critical. These are the people who plan and design electrical networks. The tools they use are called Power Factory by Digsilent or PSSE by Siemens. They need to be able to understand how to do this modeling. And just because they may have worked for the likes of National Grid, it may not mean that they've actually worked in the area of network design or network planning or power systems. That is critical to understanding how grid connections work. So if you're hiring, and you should be hiring for people to build a power team, you need to start asking these very specific questions to them in the interview process. The other thing is, there's a massive lack of these people. So I think it was Richard from Manchester earlier on, Elantra, he was talking about Manchester. Manchester is run by Electricity Northwest. They have 2 network planning engineers. SSE have 5. ESB networks in Ireland have 4. Nova Grid have 8. Jacobs have 12 for the entire world. So there's not an awful lot of these people around, and they're difficult to find, keep, and train up particularly. There's hope. There is hope. You can win it. It is possible to win the game like anything else. And the thing is, I would say you've got to go grid first and then second. I think it's highly appropriate the way Warwick has organised this, put the grid people first and the real estate second. Find where the grid is, find where the capacity is, and then go find the land near it. Not the other way around. Don't come to me and say, I found this piece of land, what grid is there? Because we've one client found for a piece of land, applied for a grid connection, and the grid connection cost was £250 million. And it would take 17 years because it was a ridiculous place to connect into the grid. Build that power team. It's going to take technical expertise to do this. It's super critical for your businesses. You've got to do it. And the other thing is speed. Remember Usain Bolt, one past all the other 2? Battery guys are doing 2 applications a week. How many of you guys do it? You can't sit on these. And please, God, stop triggering transformer reinforcements. It's taking forever, and believe me, those people don't need the work. They are out the door for the next 2 decades. And my number one thing is get out of Slough.
Get out of Slough. I'll be ringing in all our ears after this. Hi everyone, I'm Ben Brown. I'm a partner at Valuations in the energy projects team, and as part of that, I unsurprisingly do grid connections for data centres. I do grid connections for lots of clients, nuclear power plants, and interconnectors, conventional renewables, and I'm sorry to say some of the battery projects clogging up the queue. So I'm going to chair this next panel on the grid. I'll hand over to the 4 panellists. Maybe not Paul, I think you probably introduced yourself enough, but the other 3 to give a short introduction, please.
So my name's Peter Walker. I'm a shareholder and director in a company called Energy Optimization Solutions, and we're one of Paul's bad guys. So we actually develop energy storage projects at grid scale, but that's only half our business. And the reason why I'm here, I think, is because we also are fully engaged with the data center market through a partner, Total Data Center Solutions, where we're helping to utilize flexible energy storage for data center sites and incorporating storage into their energy strategy to help remove pressure on their operational protocols, but also to add sustainability and carbon reduction to the way that they operate. Sorry. And we fully fund everything, by the way, just throw that into the middle of the ring.
Hi everyone, I'm Ben Pritchard. I'm with ADK, so we look at critical power solutions for data centers, mainly prime, standby. I suppose I'm here to sort of challenge the grid connection part. You know, we're building microgrids, not so microgrid, to try and expedite data centers to go to market quicker than the grid can actually supply. So yeah.
Afternoon everyone, my name is Paul Cranfield, I'm a partner at Big Digital. We're a management consultancy and we work pretty much exclusively for the data center sector, helping investors, developers, operators and end users find their way through the muddle that is developing data center inventory.
So I was going to canter through, not to dwell on it too much to start with, but sort of how we've got to where we are, where is that, and then how do we fix it, quote unquote, and how do we get to where we want and need to be. So we'll probably start with someone other than Paul, nothing personal, but you've took that on that. So there's a feeling that the system's broken and you're trying to get capacity from the grid, and grid's undergoing a reform, presumably in some recognition that it is slightly broken. And then none of the solutions quite seem to fit the bill. You've got on-site renewables, which are intermittent. You've got off-site renewables, which are there for your electrons. You've got SMRs or hydrogen, which are not quite ready. So I suppose there's a sense that it's a bit broken. Why are we here, and where is here? Is it broken, and what's the state of the current system? Whoever wants to do that.
Why is it broken is a massive question. We could probably have a couple of hours just talking about what's wrong with grid and the grid infrastructure in the UK, but also the deployment of new technology. I think we're suffering a legacy of 2 or 3 decades of underinvestment in UK grid. So all of the knee-jerk reinforcement work that's having to be carried out, and therefore we're all sitting in queues, is because of that underinvestment. I think also another component is the way that queue management has been operated in the UK grid. So as Paul was describing in the transmission level and distribution level, we've had this archaic methodology for queue management. And unfortunately, what that has promoted is that queue and the fact that you can secure a position in that queue with doing very little. You can get a land interest, you can sign an option with a landowner or a brownfield site, and you can make an application into the grid. You don't have to have that much money, you don't have to have planning permission, you don't have to have any kit, you can have an aspiration. And what that's done is it's clogged up that grid application queue with a lot of speculators, and unfortunately some of my kinsmen in renewables and in energy storage who are speculating on the value of those grid connections or the position in that grid connection queue. So it's been recognised, we know that we've got a problem, and we know some of the things that we need to do to fix it. And there's now a five-point plan being installed. It's being run by Ofgem, so as you can imagine, it's taking a little bit longer than a week. And what that is going to do is to completely transform the way that applications are treated. And rather than being a first come, first served principle, it will be a first ready, first served principle. So if you have your components, if you have planning consent, if you have the money, if you have a design and you're ready to implement, you will be leapfrogged up to the nearer to the top of the queue. Pent up capacity, I don't know if the other guys want to talk about that, but certainly we have a capacity shortage. One of the reasons we have a capacity shortage is actually in this room. And that's because you guys, the data center operators, maintain headroom. You maintain headroom between your standing operating loads and your contracted connected capacity. We know why you do it. You do it because you want to be able to expand into that capacity. But that expansion can take 5, 7, 10 years. All of the time that you're not expanding into that capacity headroom, that capacity is not being utilised, but it can't be used anywhere else on the network either. I'm going to throw a hand grenade in the room. I believe, and this is only a personal opinion, but I think we could be facing into a clawback on capacity. There is no reason why we can't have a regulatory change and a code change that will allow Ofgem to claw back unused capacity over time, which means that if you are sitting on 10, 20, 30 meg of unused contracted capacity, you may be forced to lose that. Now it sounds like scaremongering, but we've seen big regulatory change before, and there's no reason why we won't see it again.
Yes, just to pick up on that and to echo what Paul was saying, data centres aren't the only show in town. And at best, they're treated fairly with everybody else. At worst, they're demonised for exactly the reasons that we've just heard, applying for larger connections than they'll use on day one, let alone at the end of the ramp of capacity. And are going up against all of the sectors that Paul was talking about earlier on. Data centres have started to be demonised. This is not a specific problem, it is a systemic problem. So we're talking about the UK, but exactly the same is true of Germany, of France, of Ireland. And the regulators in all of those jurisdictions have been very slow to take a hold of the problem that's been emerging for some time. In the UK, as we've heard, you join the back of the queue. In Germany, there's a clawback arrangement, so if you don't use it, you lose it. In Ireland, they were issuing, until very recently, interruptible power connections, which gave engineers another challenge in terms of how do they maintain resilience. And the French have a much more political approach to everything, as they always do, relating to the Olympics and who's in power and where the mayoral elections are next. So they kind of fog the issue, but have a much more social attitude towards data centres. And as I say, they're not particularly welcome in and around Paris as a rule. I think that the data centre community are somewhat arrogant in their approach to thinking that they're better than the rest of the stakeholder group we've talked about. They believe that they can fix some of these problems with money. How much money do you want to fix it? We've got plenty of money, let's not worry about a little problem like getting in a queue. Unfortunately, most of the regulatory frameworks make it almost impossible to spend private money on public infrastructure. So there's a kind of fundamental lock in the system if you think you're going to get your way out of the problem by spending a lot of money. Did Octopus Energy suggest they're going to start building pylons in the UK? That sounds like a good idea. Not. And so you can see kind of, engineers love the challenge, they love an opportunity to be innovative. And sometimes that kind of cuts against, the status quo and just getting into the queue. I think there are kind of bigger problems at play here. I think, the scale of data centre rollout, the capacity that's being demanded, and simply the generation capability in the UK is going to become a bit of a pinch point. Our host will tell us about Hinkley Point, I'm sure, 3,000 megawatts of capacity, £56 billion, taken 10 years to build. Probably take about 3 years for the data centre community to consume that, especially given that it's low carbon because it's nuclear. We can have the debate about that later. So yeah, this is, as I say, it's not a specific challenge in the UK. This is systemic, and it's extending to the next tier markets. So it's extending to places like Warsaw and Milan and Madrid, where you're finding industrial parks and business parks, which are already constrained for exactly the reasons that Paul was talking about. That transformer infrastructure is at or beyond its capacity and awaiting an upgrade. All of these companies have their roadmap for their own investment plans. And if your kind of particular area of the country or business park is not on that plan, well, you're going to be waiting quite some time.
Feels like there's a few moving parts and creaking pieces all at once, and there's clearly there's a lot of changes that need to be made to fix it. So I'm not asking for every change, but in your view, what are some of the key changes that need to happen to get where we want to be? And I'm not just talking about dry regulatory changes, I'm talking about changes in terms of how data centres view their siting decisions or their power decisions, or short term, they've got one problem with capacity that they needed yesterday, but longer term they've got to think about how to do it better in the future. So what can they do?
Yeah, so I think from our side it's more the data center market now needs to see energy a bit differently. You know, whereas before it's been we get grid connection and that's how it works. The demand that we're seeing outstrips whatever the grid will be able to do, especially in the UK, but we see it across Europe. So the way energy is sort of seen in our market is really, really important now, and it's a blend of technology, be it grid, be it batteries, be it reciprocating engines, biofuels. It's opened up this whole challenge of engineering that allows us to be quite sort of inventive in the approach of how we solve the problem, and we've sort of painted ourselves, or the market's painted itself into a corner. We looked at this sort of 5-6 years ago about building an off-grid data center, and it was never going to happen, and now that's real and it's happening just because they can't physically get the grid connection, and there's not a site down the road that has the grid connection that they can sign. So I think it's a mindset change from my point of view, in looking at how we can solve the problem with the tech we have now, with a roadmap that's a bit more sustainable, with roadmaps for sustainable fuels, with sort of carbon capture, heat rejection, and how we capture that and utilize that around and create this sort of ecosystem around the data center that uses power and energy in a more efficient way.
Two kind of points to add to that really. I suppose like any risk, diversification is going to be kind of your key strategy there, and that's diversify obviously geographically, you know, depending on which substation you're going into, but also in terms of size, capacity size. So I think we're going to see a range of a portfolio, you know, individual data centers having portfolios of different sizes and different ranges and different locations serving kind of one availability zone. So it might be that you physically have to split the site into 2 different grid connections, have some, you know, on-site generation as well. But the other piece is, as Peter was talking about, in terms of that kind of 20% stranded capacity, which is, by the way, the worst concept that you can think of if you're a system planning, power systems engineer, is a stranded asset. It's just the worst thing you can do. So you're doing that for them. What I would say is flexible connections, and this is what comes into batteries and to renewables now. Nobody is getting really a firm connection. They're rare, they do get them. But it's the concept of a firm to a point and then flexible on top, and the ability to ramp up and ramp down your electrical demand based on what the grid can take at any one time. And there are ways of obviously forecasting that ahead of time so that you can shift. I think Louise was talking about shifting your computational load around, but taking into account the fluctuations in the power availability to then also feed into what's going to happen in terms of your computation load. I think that's going to come on through. So it's going to be much more kind of flexible balancing rather than just this steady flat load going through. And if you're able to actually come up with that solution, you will get grid connections much more easily, much more cost effectively.
I think that's a great point, because flexible connections, when you're talking about export or generation projects, I think people understand quite a lot about that. I can't export at certain times of the day, so I now run my financial modelling against that curtailment profile, if you like. The same can be applied to import connections, demand connections, where that predictability of a curtailment strategy would allow you to backfill energy storage capacity to soak up that risk, for want of a better description. Transformer failures, look, we've got 50 years of operational data on how transformers behave and how they have behaved. The operational impact of other demand centres that are perhaps on the same piece of your network. Using storage capacity to then take out the risk of that curtailment means that you'd be able to go for flexible connections. The other thing, I think, looking at that headroom point again, and not blowing energy storage's trumpet, but that's my business, so why not, is that the headroom that you have can be used. So if somebody turns up knocking on the door and says, can I have that capacity back? You say, well, you can't have it back, I'm using it. And you can use it for on-site storage. So you can operate in the headroom between your standing load and your contracted connected capacity, and then you can displace imported energy at other times of the day. So by doing that, you're relieving stress on the local network, for which you will get brownie points. But it also means that you'll be able to quite legitimately say, I am using my connection capacity, I'm using it to charge up an energy storage asset. So I think those are things to think about from a positive point of view.
Have you seen, because I've been involved in batteries for a long time as well, and since 5 or 6 years ago, when you have conferences about the benefits they'll bring to the system, including deferring reinforcement works, that's yet to materialise as far as I can see. I mean, real way.
That's starting to, it's finding its way now. I mean, we're making what are called expressions of interest applications for large-scale grid connections, and not really this audience's interest, but it's kind of linked in that if you can prove that you can add resilience and flexibility to a local area network, because you can absorb energy in periods of low demand and you can discharge energy in periods of high demand, that will be taken favourably in network studies.
Yeah.
But it is quite geographically specialised. It is about the performance of a given network in a given location. So.
The batteries have only just been given a look in because
absolutely
their proper impact.
Literally the last 6 months.
If around Ida, for instance, a lot more people are starting to co-locate batteries to make room and headroom, would that not only help them with their own problem, but the network reinforcement works in the area and sort of unlock the whole thing?
If it means that the operational profile of peaks and troughs in demand is smoothed out, then yes, it will reduce the need for more transformers.
Yeah.
But it's taken a long time for network engineers at the DNOs and at transmission to get their heads around that, because like everybody else, they just add everything up. The what if scenario is I've got that load, that export, I'm going to add that all up, and that it could happen, and that's the kind of risk that we're playing with.
Paul, I don't want to move on before you've had a chance to talk about that, but
I was going to bring nuclear back into the landscape simply because it's in the timeline that we're looking at. We were talking about what's happening in the next 50 years a few months ago, but what's happening in the next 10 years will be the development and deployment of SMR. That's what's expected, and the extent to which those solutions will be deployed in an urban environment is yet to be tested. But to be fully successful, I think it probably needs to have some credibility, certainly in the data center space, which traditionally will have quite flat demand loads, traditionally, and therefore feels like are good candidates for sort of 200-300 megawatt SMR arrays for campus locations. A lot of licensing, a lot of permitting, and quite a lot of clear water between now and then. But low carbon and and modular and can be deployed in any environment if you get the licensing. I'm not sure I want to live next to one.
Because technically it looks good. Base load, scale, uninterruptible, and in terms of the pocket, the depth of the pockets needed on both sides also works, but it's the permitting side and the affordability side at this stage.
And I think if it's a fait accompli and it's not going to happen for whatever reason, then we probably should stop the program now. Because if it comes out a jolly good idea that we can never deploy, what's the point?
Yeah. Well, I was going to ask about that because there's a lot of large changes. Some of them are dreams, some of them are actually happening now, some of them are coming. You've got SMRs, hydrogen, the grid reform itself is one of the changes, large scale BESS, all sorts of things. In your view, what's the ones that are not likely to make a dent, and what's the maybe easy wins, or the ones that are going to make a difference?
I've no opinion at the moment. Great. Seriously, no opinion. I think that hydrogen, gives me cause for concern simply because it's difficult to manufacture, it's difficult to store. We have kind of it's not impossible. We have kind of dreams of putting it into the national gas network and using it as a supplement to methane. I just think it's energy intensive to produce, whether it's produced from renewable sources or fossil fuel sources. I just kind of.
I suppose what I'm trying to flush out is there's a lot that make a lot of noise without being necessarily something that's going to land a punch and move the dial on it. So we're trying to figure out what's the ones that are flying below the radar that people aren't thinking about that aren't generating confidence material.
I think it's two sort of trains, isn't it? It's the tech that actually is going to work, either turbines, gas reciprocating engines, batteries, but then it's the fuel as well. The actual fuel R&D is what drives that, and I think the two actually don't really talk to each other at the moment. If we look at the work we do with Rolls-Royce, we've got a full roadmap till 2030 of what fuels all of their current product will be running on. When you really dig into that, it's kind of, well, yeah, our product will run, whether the fuel's available, that's a different question, right? And I think that's the bit that makes that question really hard to answer, because from a tech point, I can sit and say, I know that reciprocating engines will run on hydrogen in the next 10 years, but will they get green hydrogen to run on that makes it feasible? Probably not. You know, so I think it's a really hard question to sort of answer, I suppose, but I would say it's more on the fuel itself, from my point of view, that needs to sort of or their feet need to be held to the fire a bit.
I think it's a combination of renewables and storage, because if we can get rid of the intermittency of solar and wind, and we can store that energy with long duration, and we're in the short duration business, but long duration technologies are arriving. If we can design a decarbonised grid, so when we take those electrons across the meter, we know exactly what the carbon intensity is of that power. By having decarbonisation targets, which we're working towards, but it is taking a long time, is have a design for a UK infrastructure that allows the wholesale bolting on of more renewable capacity, and then we control it. We control it by the use of storage, and that might be hydro storage, it might be gravity, it could be. There's all sorts of different techniques and technologies, but we need to be able to, just like we did in Victorian era, where we decided that gasometers were a good idea and we could store gas and use it when we needed it. And we need to be able to do the same with electricity. It sounds trite, but I think it's a fairly simple approach to solving that conundrum.
So we're starting to run out of time. I'm going to ask a slightly cheeky question to Paul. It's not cheeky, but with Ivo, right, in terms of flower. Are we just going to end up with the game like watching a kid's game of football where they all run after the ball around the pitch together, and we're going to end up with an Ivo 2.0, or is there going to be another cluster like that? Do you think? Where are you going to be telling us to get out of next, or is it is that lesson learned?
Yeah, I mean, I suppose the one thing on this is yes, is the answer to your question. We are going to end up with a bunch of minis football players just running after the same ball, but there's no end to the game. There's no final whistle. As soon as capacity is built, people will come in, make their applications as quickly as they can, and use up that capacity, and then they'll move to the next spot. And the game never ends. It keeps going from location to location based on whatever society needs at that particular moment in time. The grid is the biggest machine humans have ever made. It's the biggest emitter of carbon, but it reflects our societies and how we use and need the energy that we do to live the lives that we want. So unless our lives are going to end, the grid will never end, and the capacity game will never keep going on. God, it's very philosophical.
Perfect way to end. Thanks for that.
Huge thanks again to our panel. Again, power has been on the agenda since I first wrote my first ever data centre programme back in 2000. And we're still talking about now, but the conversation's changed slightly. We certainly weren't talking about nuclear all the way back there, and it was just that we had no idea what the demand was going to be, and it's great to see that there are things in the pipeline that might end up being, and he said storage, going back to olden times, it's not always reinventing the wheel, it's using things that have worked previously. The other thing that has been on the agenda since 2000 has been land, and that's the session we're going to be going to for our final session. So thanks to our panellists on power. And then Alex, last but not least, Alex from Knight Frank. We'll be talking about land availability to round the conference off. So over to you, Alex. Apparently so.
I see.
Let's move.
Around till the end of the agenda. I suspect many of you are here because there's beers in approximately 35 minutes time, but hopefully we can cover a little bit of new ground. Unfortunately, some of the topics we wanted to cover have been somewhat cannibalised by some of our previous speakers. Mark, where are you? You're 100% guilty. But hopefully we can add a little bit of a twist on it. I think the idea of today really is to discuss just data centers from a real estate perspective, whether or not that be land, whether or not that be power availability, whether or not that be AI. There's lots of things to discuss, but primarily, where are the data centers going to be built in the UK in the future? But what are the hurdles to that growth as well? We've talked a lot about what's driving growth, but what can hold it back? It's power, it's land, it's public opinion, it's cost, it's lack of capital. There are a lot of things that need discussing. And with me today, I've got a panel who are more than up to the task. What I might do is let you introduce yourselves, if that's all right. So, Chris, do you want to go first?
Hi, Chris Coward from BCS Digital Built Asset Consultancy. My role predominantly sits across the whole operation of the business, so I see data centre development, construction, right through from site due diligence through to testing and commissioning these data centres, so I get a whole overall profile of how these things are built.
Hi everyone, Stuart Jarvis, Investment Director for Capital Land, based in London, but our headquarters are out in Singapore. We're predominantly here to bring Asian capital into Europe. One of our strategic focuses is data centres. We have about 600 megawatts globally, either built or being built at the moment, and hoping to continue to bring that to the market.
Simon Ransell, Senior Director for Real Estate Expansion, EMEA for Versus Data Centres. So we are probably the largest UK data centre operator at the moment, and expanding into Europe. We've got sites in Berlin, etc. So my responsibility is to find sites, down select them and acquire them. Previously worked at AWS for 5 years, looking after their real estate for the UK.
Hi, I'm Siobhan Nagel. I look after real estate for Equinix across EMEA. Also actually late of the parish of AWS, and Equinix, as you know, is a digital infrastructure provider globally.
Great. Thanks so much, everyone. So, first question. I think probably one for you, Simon, and that's there are kind of a number of things that are impacting not the wider real estate market, but data centres haven't been completely isolated, and that's increased cost of debt for starters, but also significant increase in cost. Some of that gap might have been bridged by rental growth, but in your opinion, has it been completely bridged, and also how is that impacting your site selection and site feasibility?
So dealing with the first part of the question, really, I think typically up until probably relatively recently, deals have really been done on historical pricing. So really, I think it's starting now. There's a bit of a lag, but we're now starting to see the rents in terms of what we can charge to our customers are starting to catch up with the inflationary pressure that we've seen since Ukraine and various other global events. So we are seeing movement in the rents to compensate for the higher costs, but we're only, only if you've been building in the last 12 or 18 months, that's when you've really started to see those impacts on costs for us anyway, I think. So you know, that to answer your first part of the question, I think in terms of site locations, I mean, it's kind of interesting because listening to the panel before and about power constraints and get out of Slough, I'm sure you guys, Mark at Seagrow, is probably very happy to hear that message. The pricing on the real estate piece, dare I say it, is actually a relatively minor sort of nudge on the needle of the overall cost and what we do. So really, you know, pricing on land is interesting, and obviously nobody wants to pay too much for land, but actually, you know, now it's a global kind of business. We pay pretty much the same for equipment in the UK as we would do in France or Germany. There's a sort of parity of geographics, etc., that might change that a little bit. But so the land piece doesn't necessarily drive the cost decisions that we make in terms of site selection. It's principally about the value of the site as an operational asset location.
I think the land agents in the room will probably be delighted to hear that. And actually, so sort of sticking to kind of increased costs and some of the kind of construction issues that people have had. Chris, you're kind of on the front line of ensuring that, you know, data center schemes are delivered, you know, on time, on budget, etc. You know, yes, we've seen a lot of cost inflation. What other headwinds are we seeing in the construction world?
I think we've touched upon it today quite a lot. Net zero requires data centres. London is full. What are we going to do about it? It's not a matter of if we need to move into secondary locations, it's when we move into these secondary locations. And on the back of that, these secondary markets, secondary locations is the heart of industrial England. So we can go back to the industrial England and we can drive these new data centre locations, the likes of Manchester, the likes of Leeds, Liverpool. All those locations are places we can move into. Land costs are a little bit cheaper, construction costs are a little bit cheaper. From our perspective, we've seen a lot of clients come to us saying, what are the costs going to be in these locations? How long is it going to take us to build in these locations? Is there power there? Is a big question, of course. We've always got the same challenges: cost, skill shortage. Is there people there to build it? You can move people around the country, but if there's no people in the country to build it, we've got the same problems. And one of the biggest challenges is the rapid technological advances. We're seeing projects that we're ripping out kit we put in at the start of the project because IT has moved on so much. So we need to work out from our perspective what we want at day one and making sure we can deliver it in the timescales and to the cost that the client requires. And the secondary locations from our perspective, they're cheaper. They are going to be a little bit cheaper, but not hugely cheaper. We're seeing 3%, 5% maybe, but by the time we factor in travel of individuals, labour shortages, the costs do increase. So you're not going to get huge savings by going into these secondary locations.
Fine. I mean, there are locations within, I suspect, in West London and the Docklands that are significantly more expensive. On kind of what would be your benchmark for sort of 5% of it? Is it sort of Slough versus Manchester? You're talking maybe sort of 3 to 5%.
Yeah, you're talking build costs. It's sort of 10.3 thousand a kilowatt to 10.7. You drop to 9.9 maybe per kilowatt if you go into these secondary locations allegedly.
And we've talked a lot today about kind of hyperscale demand, hyperscale development. Siobhan, you're being at Equinix, you're focused on, you know, a whole range of the market, including the retail market and the enterprise market. You know, how are you seeing demand? How are you seeing the market change in your sphere?
There's growth is probably the only word to use, and it continues at a rate of knots. We're not seeing any huge slowing down in the market. As I say, the growth continues, and also, of course, from our xScale product, which is at the hyperscale market, which is a slight change of tack for Equinix, but that's where we're going, and the growth is there as well. It's the same challenge as everybody else has just discussed. It's where, how do you get the power, where do you get the land? So, you know, of course there's growth, of course there's demand, because there's lack of supply.
That's also the battery operators have hopped a little bit.
Yes,
don't forget that.
Absolutely.
So, I mean, Stuart, it'd be really interesting to see what you think about sort of the UK market looking in from the outside. Clearly, Capital Land, Singapore-based. You know, what's they're away. You know, what's their focus? What do they see happening in the UK that's of interest to them?
I think one of the dynamics at the moment is debt costs. They've clearly spiked over the last year. What we're starting to see is come an arbitrage between the cost of capital in Singapore versus over here. So now we're becoming quite an interesting JV partner for developers in the UK, where our blended cost of capital is starting to look cheaper than the UK or European capital. Similarly, if it comes to an outright purchase, we're now getting a position where, frankly, we can just afford a bit more because the cost of capital is cheaper. So that's one of the main movers of the market. Otherwise, we're kind of agnostic and passive. All the other impediments to development the guys are talking about, we just have to wait till the investment hits kind of the crosshairs of what we're looking to do. And when it does, we pull the trigger, we can invest. Otherwise, we're not kind of forced to invest. We're not under time pressure. We're not looking to hit specific targets in terms of rollout. So we can sit back in that respect.
Okay. Well, actually, you've touched on something I was going to sort of comment to next, and that's access to capital. Obviously, we need operators need more and more. Simon, probably another question for you. You know, you're seeing a variety of different methods to raise additional capital, whether it be through part sales of SPVs, whether it be through potential IPOs. What do you think is going to be the sort of most popular methodology for raising new capital over the next kind of 2 years or 3 years?
Yeah, that's a good question. I think for us, I mean, obviously we have our key investors, SPV and Macquarie Asset Management. I think, but in terms of recycling that, our sense is that, you know, as you talked about sort of debt, interest rates, etc. Hopefully they're going to start to unwind a little bit, and I think as that happens, I think there's going to be more access to that. It's going to be very competitive still, so really, I think to really be able to benefit from better rates, we're going to have to demonstrate our reliability as a sort of service provider of choice for data centres. The good operators, I think, will stand to have better rates against their debt ratings, etc. So that's the way that we're looking at it.
I mean, there are a lot of new players, and I don't know about you, but I mean, every sort of, well, I say there are new players, there's some announcements about new players. A lot like this, little announcements about new sites. You know, not all of them come to fruition. But there certainly are more players in the market, but then at the same time, we're hearing a lot about consolidation as well this year. I mean, PTC, for those that were there, it was a hot topic. You know, are we going to see more rationalisation within the market, more M&A? Siobhan, I don't know if this is something to touch on, but you know, in terms of what you're seeing, obviously as a publicly listed company, you know, you're looking out at the rest of the market. What do you see happening in terms of, you know, new players, existing players? You know, where do you think the market's going to go?
Okay, well, I suppose a lot of consolidation has happened to a certain extent when you look at the investments of, say, the Brookfields, etc., etc. And then you look at how it's narrowing, and we look at, say, the number of new players coming in and what really are their hurdles and their point of entry into investment, the longevity, the relationship with the customer. Any of us in this room who've dealt with a hyperscale customer, or actually been that hyperscale customer, know how difficult it is to satisfy their needs and requirements. I don't know how many of the new players can actually achieve that. So is there going to be consolidation? Probably, and probably quite a lot of it. What do you mind?
Something else that's probably something a bit of a selfish question, because it's of interest to me in particular as a valuer. You know, the stabilised value or the exit value for a lot of these new schemes this year, I'm going to be asking you this question, so prepare yourself, are huge, right? We're talking billions, you know, for single assets or single campuses. When you're looking to exit that investment, you know, you're going to be a pretty rarefied pool of buyers potentially. You know, and it'd be interesting from your perspective to say, and you know, sovereign wealth is going to be one of them, where you think that capital is going to come from to potentially keep driving this market.
Yeah, and you look at kind of three strata. So your low risk, low return pool of capital is going to be infrastructure investors. They've got clearly very deep pockets. I think there is a mild question mark over how tightly data centers fit in with an infrastructure. I think there is a leasing risk behind data centers. For me, it's a question mark. It's probably a discussion for a longer session than this one, but infrastructure is certainly a pool I would look to. Clearly, they're very technologically aware. Second after that is where I sit, which is the real estate investment trust, the REITs, as well as property funds. Some will have very deep pockets and will get their head around data centers. So that will always be your sure and steady kind of pool of capital, looking for a slightly higher return than the infrastructure guys. The third pool is a bit more racier, it's private equity, and it kind of depends what they're looking to achieve. Very often they're about aggregation, building platforms and selling. I sense they may now be out of the market because sort of the fast money, well, I say quick wins, it's a long time to make money in data centers, but I think their money may now be stepping back unless they're looking to build a platform. So for me, the 2 or 3 pools there, I'd say infra and the REITs such as ourselves.
Thank you. And Chris, when we chatted prior to today, one of the things you mentioned was supply chains and capacity rather than actually kind of increased costs. So I'd be really interested to see how you think it's going to impact the growth of the sector, because at the end of the day, if there's not enough kit and there's not enough people to build the kit, then these things aren't going to get built.
Yeah, I think from our perspective, we get a broad range of projects, so we work for everyone. So we know the projects that are coming up, we know the capacity of the contractors. Everyone has got limited capacity at the moment. It's not just in the UK, it's in Frankfurt, Amsterdam, Milan. Everyone is overstretched. So it's about managing and working closely with these contractors. We've all got an obligation here to work together to get these things built. And if we don't, we just throw it on a contractor's plate. It won't get built in time and to the necessary quality, the necessary health and safety. So we need to be careful not to overload contractors in any way, shape or form, otherwise we just won't get these things built in time.
Yeah, no, absolutely. And delivery is key, right? I mean, your nation will, I tell you, don't deliver in time. I suspect you've given a few people a telling off. I mean, look, we're going to get on to the obvious topic, which is power and lack thereof. I mean, okay, West London's a fantastic example. Either B is going to be delayed. I think someone mentioned earlier that there was a healthy pipeline of development in West London. Do I agree with that? Yes, but is that enough to last 5 or 6 years? I don't think so, particularly if we'll come on to AI in a bit as well, if we've got time. Given the limited resource, and Simon's probably a question for you, and again, so we've come on to this before, but interested to hear your take on it, is, where's next on that basis? Because West London, Stockley Park, Slough, there's power around and there'll be more power in the future, but there's quite a big gap. What's going to fill it?
Yeah.
Data in Manchester.
So, I mean, from the UK, what we're experiencing in West London is exactly the same as what's happened in Dublin, Amsterdam, Frankfurt, Paris, etc. And going to tier 2 markets, the same thing is repeating itself again. So you go to some markets and there's just an abundance of people that have land and power and connection offers in some form or another. So it's just a repeating pattern. I mean, I think for us, where we've had success is finding large-scale campuses, and where the tricky bit is it's all very well saying we need to go to places where there is power. I think the missing piece of that jigsaw is the connectivity piece, and so I don't know, I haven't been here all day, so I don't know whether we've had the conversations with anybody on the fibre side, but obviously the developments in new fibre will help us exploit other locations, really exploit in the best sense of the word. Yeah. Look at other locations, but I think we'll be very much, we have to be led a little bit by our customers and try and solve their problems ahead, think through what their problems are going to be. We've done that very well in Germany, where we've got a hyperscale 300 megawatt site, all renewably connected, etc., where we can get behind the meter. And that's what we want to try and replicate, but they're not easy things to find.
Just to guard up on that, I think we need to flip the mindset here. It's not campus delivery, it's an infrastructure delivery. Yeah. It's not a box of stuff coming into it.
if we need to think about the infrastructure, the wider communities, if we get that support and buy-in, we get government support, and we can get vested interest in developing these things, and it should improve speed to market. It should improve
government
delivery
support is
time.
an interesting one. Public opinion is, I mean, we can lobby all we want as an industry, and perhaps we're not as good as we could be at that. I think someone made a very good point earlier, which is, more than a couple of sentences, people kind of nod off. But, it's about public perception, which is still, really poor, not helped by, sort of certain programs. That is something that I think potentially this year is going to be a bigger and bigger risk, and any legislation that comes in off the back of it. So, on the fibre piece, are sort of subsea landing stations and the areas around them going to be, a lot of people have done it in tier 2, tier 3 markets. That's where they bet on, demand. Do you think that's a reality for something like the UK?
It's difficult one to be specific about. I'm not a network guy really, but I guess the only example I can use from my experience was, when the easiest way to deal with these issues was to, when it was starting from scratch with a brand new region. So when it was at AWS, we did that in Spain, and we selected somewhere where we weren't looking to go to Madrid or Barcelona. We went somewhere where we could get abundance of renewable power, where working with the community, as you've mentioned earlier, Chris, worked very well because it was bringing new high technology to a sort of unknown market, the logistics market from a real estate perspective at the time, and it gave AWS the ability to scale and grow. So that's easier. Whether that's the actual subsea cable landing point didn't really impact that decision. So it would be useful, but it's not necessarily the driver for us.
I'm going to come on to AI because what panel would be complete without AI? 5 minutes, okay, we're all going. I think a concern I get asked a lot by investors is, and someone has touched on it briefly, is covenant strength of new AI, non-cloud backed AI. Actually, Stuart, maybe you can pick this one up. It's a real risk, right? And you're looking at voids and a very specific build potentially. How likely would it be for you as an investor to select an AI tenant that's paying £5 or £10 more per kilowatt over a cloud provider or or a safer company? What would be your choice in that scenario?
I think you'd probably be a bit shy of the AI covenant. I mean, it doesn't have to be AI, clearly. Any weak covenant strength, you want to think twice about. As a REIT, you're all about that recurring income over a 5-10 year kind of investment horizon. If you have any doubts over the covenant strength, as a valuer, you're going to put a weaker cap rate against it. So at least balance out the capital value and need a higher rent to play off against the weaker cap rate. But I think I'd be reticent to take them on. Unless behind it, they would say a VC backer offering a guarantee, some sort of surety deposit. I mean, I'm not a technical man, but to unplug the infrastructure that's gone bust will take you time and an awful lot of money, I'd imagine. So it's a tricky one to financially model, where you have to program that in, and at the very least it'll mean higher rents and some form of deposit, I would imagine. If you can't get that, I'd step back and probably wait for, frankly, a better tenant.
Absolutely. And Sean, how location agnostic is AI in reality? Because there's all sorts of different types. Is it a case? Can we just go and build in Redcar? I know Chris will mention that. Is that really a reality? Unless it's.
I think there's probably certain forms of AI can be built in remote locations. So the machine learning piece, where you do not need instant connectivity to our phone, we can go further afield there. However, anything that requires greater speed and that can't live with the latency, well, it's going. I hate to say it, hello Slough. We're back there, John Vetchman, come friendly bombers. But it is, that is the reality. You still have to be close to where your customer wants you to be. And I think we'd all love to say, we can go and decentralise completely. I don't really see it happening yet.
Yeah, I think, sorry, just to add to that,
No.
I think you've got to be cognizant as well when you're looking at locations for sites is around the resource, the people that you want to work there, etc. So, it's a bit weird because data centres are seen as a low employment number kind of activity. That's true, but you need quite a lot of high qualified, highly skilled people, not just in the data centre where that's quite a small sort of number of people, but the support services that come in around it, that you use on a daily basis is very big. So, it would be probably as much risk to your business to locate somewhere where you're not going to be able to get that human resource, that skilled labour. You can train them up over time, of course you can, but that's a risk to your operation day one. So
That upskilling is quite
you have to look at
interesting.
that as well.
Financial Times this morning, they were talking about Port Talbot and the steelworks, and how something like 53% of the local population are engineers by trade. Now, not quite the right engineers, but they could be reskilled. I don't know how long that would take. I'm not it's not my area. I mean, Chris, you probably know better.
From our perspective, it's about 500 to 700 individuals needed to build a data centre. So that's a campus. It's a 5-year campus. And then these people can be moved on to the next campus. So it's worth the reskilling, it's worth the retraining. But if we know the locations we're going to go to, say, 5 years' time, we can start the training now. We can start the reskilling. We can improve these people's lives. It's bad news, we're closing the steelworks, your community's ruined. Let's start retraining them now. The data centre's coming, and by the time it arrives, you'll be on site building it and build a community around the data centre.
Yeah, that's the good thing, data centres give you time to be able to prepare for that sort of thing.
And I do, there are examples in the US, right, where there are the set up sort of, university type.
Well, we participate in something at UTC in West London where we're sort of sponsors and go into the university and sort of work with the students, etc. So that's very successful for us and the students.
It goes back to the messaging of the market. We've all got responsibility here. Get the messaging out there. It's not IT, it's construction as well. Get people excited about data centres. We're not evil, it's not bad.
Maybe that's another thing, another message that needs to get home. And I think again it comes back to the messaging around data centres to the public really. It's that, yes, we do have a responsibility, but also there's a huge opportunity to change public perception, which, at the moment is not great, but could be a lot better. Great, well, thank you very much. I think our time's probably up. I don't know if there's any questions, or we have time. You're already clapping, Nick. I know there absolutely is not time for questions. That's probably a relief. Thank you very much. And,
Another amazing panel. Thank you so much for your expert chairing there, Alex. Absolutely brilliant. What is typically thought of as quite a dry subject was certainly not dry during that panel. Thank you to the panellists for enabling that as well. Heartfelt thanks to all of our chairs, our panellists, and of course our keynote speakers today. Without them, we wouldn't be able to put on this programme of what has been absolutely fantastic content. So a round of applause for everyone. To all of you, we know the conference schedule is really packed. We know you've got busy day lives and jobs that you have to do as well. So we're honoured that you chose to come along and actually spend time with us today, and I hope you found it worthwhile. I'm only going to keep you from your beer for one more second. Obviously, quite a few of you have attended our flagship event, the On Teep event. If you've not, then you're missing out. Please talk to anyone that has been there. Their feedback is better than from us. But we'd love to see you there. It's from the 10th till the 12th of September. It is very much content focused. It is the content that you've seen today, but on speed. It is a content packed, the auditorium is packed, there's still all those wonderful networking opportunities, but it's very much about the quality of what you're learning as well. On your chairs, you actually have a little flyer that if you use gives you a 10% discount on buying any tickets to Onto, and we hope to see you there. So thanks to everybody, thanks again to Evershed Sutherland. Going in
You are the chairman of the small modular reactor business in nuclear energy for Rolls-Royce. Do you see growth opportunities for SMR business in the data center sector?
There are huge growth opportunities, and initially when we formed the small modular reactor business, this was really just going to be power on grid to replace coal-fired, oil-fired, gas-fired power stations with sources of net zero energy. Then we saw other opportunities in the chemical industry, in the production of sustainable fuels, in hydrogen production. But about a year ago, the world seems to have changed, and we were approached by lots of the tech companies and data center providers because the growth in data centers, particularly driven by AI, has now meant that they're of the size where they need their own small modular reactors. and the need is very urgent. We've been at a great conference here today where we've heard the need for 38 gigawatts of energy in the next 5 years just to fuel the AI revolution.
How far ahead will SMRs be ready to deploy?
Our current schedule, and we're going through a regulatory process. So nuclear power stations have to go through a regulator that checks for the safety and integrity of the power source. We're planning on going through that over the next 2 or 3 years, then starting to build our first few and getting first power on grid in about 2030 or 2031.
And any indications on the cost of nuclear energy in comparison to other renewable energies?
Yes, so the cost of a power station, and I'll have to start switching between currencies here, is around about $2.5 billion for a 470 megawatt power station. Now, one of the things about nuclear energy is the running costs of nuclear energy are actually quite low, tens of millions of euros a year, and the cost is dominated by the cost of capital. In other words, how much it costs you to raise that $2.5 billion for each power station. Now, with a decent cost of capital, and decent, I'm talking 4 or 5%, we should be able to produce energy at around about 50 to 60 euros a megawatt hour. I'm sorry to switch between dollars and euros. But at that price point, if you include the cost of energy storage, then I think we're going to be undercutting wind. It's true that wind without energy storage can get cheaper than that, but in a real world situation, powering a data center where you need 24/7 energy with 5 nines reliability, you're going to have energy storage if you're using wind as the energy source.
Well, if we're going to meet here in a year's time, what would the story be then?
In a year's time, I think the business would hope to have a far closer relationship with the big data center operators, the big tech companies. I think we can lead them on a path that will mean we can guarantee to get to net zero with a far earlier date than we could if simply they were hoping that the market will provide the electricity at net zero. So really it's about cooperation, it's about partnership, and it's about the energy industry and the data center industry coming together because they need to.
So I have here Professor Roger Cashmore, who's going to talk to us a little bit about the climate skeptics. And could you first of all, Professor, tell us about you?
I grew up doing science at the university, particularly nuclear science was part of that, but then went on to study particle physics, which is a subset of nuclear physics. And then I've had a career in that in the United States and here in Europe. And I ended up by being the director of research at a big lab called CERN in Geneva. I'm the Deputy Director General. And after that, I moved in and became Chairman of the United Kingdom Atomic Energy Authority. And that was my introduction more into things nuclear fusion and fission.
So can you take us through a fast track from 10 years ago when nuclear was starting to be a thing, and then we had 10 years of decimated because a lot of incidents happened, and the connection of nuclear with a lot of negativity and incidents. Suddenly, now that everyone's talking about the energy transition, we're talking about nuclear renaissance. So can you explain to us why, what is the role of nuclear as a pillar in that energy transition, but also your concern, I know you have a lot of concerns about the climate skeptics.
Yeah.
So.
Well, let me begin first of all with the nuclear business. It was a great setback when we had the accident in Fukushima. And this again gave a lot more energy to nuclear skeptics, but in fact it shouldn't have done, because nobody died as a consequence of any nuclear emissions from the power plant at Fukushima. It was actually enforced migrations that caused deaths, as it had been in Chernobyl 20 years earlier, right? Not from anything from the nuclear reactors themselves. But it was a thing for people to latch on to as being something that was dangerous without really considering what the dangers really were. And of course, that played into the hands of a lot of people, and in Japan it was clearly the case, which is, remember, the only country that has ever been attacked with nuclear weapons. And there was a whole community there that did not like nuclear, and they could, every time these things, nuclear is latched onto as a bad thing. In fact, it's a very safe way of producing electricity, probably the safest that we know. And so that's where I got very heavily involved with nuclear and spending time trying to convince people, tell people why it wasn't such a dangerous event.
So, what is the risk? Is there a risk of SMRs? Let's say it is ill use or falls into the wrong hands.
I think it's for people. First of all, I think the risks are very little in SMRs. SMRs. I mean, the first reactors that were ever built 50 years ago produce the same sort of power as an SMR will produce in the future. So it's in fact not very different in a way. Those are bigger objects to deal with. But the SMR, the virtue of that is that you try and build as many components of it as possible in a factory and put them together on a site and benefit from the fact that you know how to do it, and you can do it without any surprises in trying to put the parts together. So SMRs are good. People getting hold of the fuel, right, from an SMR. I don't think there's any danger in that. It's not it's difficult to make weapons. If people want to think of bombs, very, very, very difficult to make weapons from any of that sort of material. And also to disperse it as well is another thing that people worry about. But it's not radioactive enough to be dangerous, right? The thing that one has to understand about reactors is the energy that is stored in the nucleus of an atom is enormous compared with what in a dead tree, a piece of charcoal or a piece of coal. A thumbnail's worth of nuclear material is worth a ton of coal to you. That's to give you a feeling, right, for what the storage capability is of nuclear fuels and why you want to tap them.
Exactly. So what is the role of nuclear energy in the energy transition? Why is it one of the pillars for us to get to full decarbonization or electrification?
It's one of the pillars, because actually when you build a nuclear reactor, reactors, when you get them going, they like to just give you energy in a constant way all the time. They don't like to go up and down, they like to go pour it out in a very gentle and reliable manner. The other things that we can think of for now getting energy, like solar or wind, they go up and down, and they are not reliable. You have to have another system to go along with it to store the energy at the times of plenty, to cover the times when you've got not very much. But the reactors give you a bedrock on which you can keep everything running, right? That's why people like them. And once you've got them running, they will run for a long time without any interference until you need to refuel them. And that's only about once a year, right?
So before we came and sat here, you're expressing a bit of concern that in the world there are still very vocal people, very powerful, who are climate skeptics. Can you give us an example of who you think is someone who is detrimental to the development of green energy industry? And what do you say to the climate skeptics?
Well, I have a lot of unease with quite a large number of people in the political world, particularly, And we see it at the moment. We know that in Britain, where we're sitting now, that there's going to be an election within the next 12 months. And politicians are taking decisions which don't put off some of the things that will cut down CO2 emissions. They're putting them off because they will, if you do go along with that, you put up the cost of living, as we say in Britain, and that they think will lose them votes in an election. So that, in fact, that's what I'm sceptical about. They're trying to rig it for themselves on the short term. For instance, the current Prime Minister, Sunak, in Britain, he's now pushed through that we were going to stop the sale of all petrol and diesel cars from 2030 onwards, new cars, and they were therefore replaced by electric cars. He's now pushed that back to 2035. That means there will be a longer market for fossil fuels, more possibility of CO2 going up, and in fact, we should already have turned over and been going down in CO2 to make the climate objective of 1.5 degree rise by 2050. We ain't going to do it now, right? I'm sure of that. But it's soon you've got to start cutting down the CO2 because it hangs around in the atmosphere for 100 to 200 years. So if you do something now, it's going to be with you for the rest of this century.
I guess what we're all saying is when an issue is politicized, this is when it gets diluted. So I guess we moved into an era where the climate issue is getting heavily politicized. So this is where a lot of people like you need to come back in and make sure to keep it on track. What is final question? Have you followed COP28 and have you got any comments on the outcome?
I've been following it. We haven't seen the outcomes yet, of course. We've just seen all the declarations. And I mean, there are some interesting ones, but you notice, for instance, the number of the 22 countries that have agreed on a statement that they will increase the nuclear capacity by a factor of 3 by 2050, which will help, of course, it will cut down emissions. But of course, that doesn't include India, China, or Russia. They haven't agreed to doing that. So the big players in the climate world are China, India, and the USA.
Interesting.
Right?
Do we understand why?
Because they don't like to be. I have no idea really why. Because they don't like to be bracketed with the West, I expect.
Well, thank you very much, Professor, for your time with us. And this was Lina Tagliare at StockTech.
Okay, thank you. That was right for you. Establishing nuclear new build in the energy transition. And that for me is the vital thing to do. I believe nuclear is important in all of this, but really it's solving the climate change and energy issues, which is the paramount importance in everything we're doing from now on. So let me just remind you of what the situation really is. Notice this is a thing you can get off NASA websites, NASA temperature spiral, and it begins in 1880. And I think it's always good to actually refresh one's mind about what the problem is we're trying to solve and to deal with. And here you see, over the last more than 100 years, what's been happening to the temperature in the Earth over the year. And as you can see here, it's all getting a bit warmer compared with 1880. And it starts to get a lot more warmer in the 50s and the 60s. As you can see, going out in size. And then it starts to really take off in the 80s and the 90s. So here we go, right? You can see the temperature going and growing, and it's now at 1.5 degrees centigrade, more or less, up some of the time. And here it is roaring up at the present time. And I think it's good to look at this, just to remind you of what the situation, what the job is that we're doing. And there you can see the spiral, right? And you can see the majority of that this change has come about because of stuff that has occurred from this point onwards. This is the 1990s or so. So it's really taken off. And that's what we're worried about. Worried about that temperature spark keep on going, and it's going because it's driven by CO2 or greenhouse gas. You can see here the world's energy use. Then after the Second World War, it starts to take off, and it takes off and goes up and up and up and up until we've got this amazing amount of energy that the world is consuming. It's fossil fuel driven energy. It's 85% or so of the energy that we consume in the world is derived from fossil fuels. Right? That's the problem. So we've got to get out of that one way or another. So if we do that, the issue is really dramatic, because what we're doing is we're saying we're going to replace 85% of the world's energy supply by some new supply, new supplies, which don't involve fossil fuel at all. Okay? So that's a mammoth task. It's taken basically 80 years to get us to this situation. So what we're going to do, if we want to get rid of fossil fuels by 2050 or get rid of CO2 emissions by then, we've got to do in 20 years what it took us 80 years to construct. That's the problem of our society, all of us. And the emissions of greenhouse gases, CO2 and methane, are the main culprits for that change. CO2 remains in the atmosphere for over 100 years, and it's very mobile, CO2. If you burn something in China, some of the CO2 molecules within a week or so can be around the other side of the globe. So there's no way you can evade this climate change unless you solve problems for the globe. And just as a reminder, methane, why everybody gets so excited about it, is about 35 times more potent than CO2 as a greenhouse gas. That's why there's all the interest in cutting down methane emissions. The only one good thing to say about methane, it's not a very good thing to say about it, when it breaks down in the atmosphere, and it only lives up in the atmosphere about 20 or 30 years, it breaks down and the product is carbon dioxide. The emissions in this year, 2023, are greater than the ones in 2022, which in turn are greater than the ones in 2020. We haven't flattened off in carbon dioxide emissions yet. So it's only going to get worse, as they say. The largest polluters, if you look at it, which these produce, are China, India and the USA, followed by Europe, which is where we're talking about today. But these produce about 50% between them of all the CO2 emissions.
We do a renewable
Hi, this is Nina Tayana, that's Contact, and we're here today at the 8th European Nuclear Industry Congress.
Investment opportunities in
So nuclear is having a renaissance, and we're here to find out how and why.
We've already had 3 power stations closed since 2021, and another 4 of the 5 remaining nuclear power stations are scheduled to close by the end of 2030. Quite rightly, this is a significant draw on nuclear skills to decommission these power stations and return them to brownfield sites. The other consequence of the declining operational capacity is the need to replace it with new nuclear. So the UK government's energy security strategy has set out requirements for 24 gigawatts of new nuclear by 2050. And if we try to put that into perspective, there is 1 nuclear power plant in the UK currently under construction, Hinkley Point C. That will have operating capacity of 3.2 gigawatts, so less than 15% of the requirements. Therefore, again, in the UK, the scale of the challenge is huge. In addition to the civil requirements and the energy sector, the UK government has also announced the renewal of its nuclear warheads. Given this is a critical government policy and critical for national security, again, this is a draw on some of the nuclear skills that we have in the country. All of this combines into a perfect storm of demand for skills. Now that we understand a little bit about the demand for skills in the UK, in order to inform our recruitment strategy, we need to understand the makeup of the current workforce. Fundamentally, if we continue to target the same talent pools, we will exhaust those quite quickly. We need to expand our reach to all segments of society. On the screen, I have some stats from recent surveys. So in 2021, the nuclear workforce assessment found that 20%, or approximately 20% of the UK's nuclear workforce was women. For those in the room who are familiar with the nuclear sector deal, there was a target of 40% of women in the nuclear workforce by 2030. Clearly, we still have some work to do, especially as the percentage hasn't dramatically changed since 2019.
Nuclear energy and renewables. And let me just go into some of the major goals we have formulated. First, energy sovereignty. Second, energy security. Third, preservation of utility reduction policy, which means a price cap for our households, energy for households. And what can underpin this? Well, provision of low-cost energy sources. And fourth, decarbonization of energy production. The Hungarian consumer is in the focus. We want to strengthen our security of supply. We also want to facilitate a carbon-friendly transformation of the energy sector. And we also want to capitalize on the innovation potential and the economic development potential of the energy industry. So, what are the main directions or interests we have pointed out? First and foremost, the reduction of reliance on energy imports. That's very important to a landlocked country which is not really well endowed with natural resources nor significant renewable potentials. It has regional gas and power interconnectivity, renewable-based cooling and heating systems, the expansion of e-mobility, the household energy production, which means first and foremost PV, solar panels. And here comes the thing, last but not least. By 2030, we want to achieve 90% of our power generation to be carbon neutral. Right now, it's between 60 to 65%. And by the way, out of this 60 to 65%, roughly 50% comes from nuclear energy. So you can see the focus how we want to achieve energy transition to carbon neutrality. We believe that all low carbon energy should be part of the energy mix. This is what can satisfy growing energy demand, growing electricity demand, and of course, clean electricity. Decarbonization is not possible without the use of nuclear energy. We are very pragmatic on this approach. We totally refuse the ideological policy making, which unfortunately some European countries have adopted in the past decade or so. And how are we going to achieve that? First and foremost, the framework, the policy framework. I already mentioned the National Energy Strategy. The energy strategy outlines the key framework, and how we're going to do that? Well, this is written in the National Energy and Climate Plans. These are required by the European Union. We have to update this document every 5 years according to the regulation. We have just submitted, by the way, this year our new version or updated version, which is reflecting already the events of the past couple of years in the energy market. And we have to reflect on those. We have to reflect on practical issues. We have to adjust sometimes our approaches without changing the key target, carbon neutrality by 2050. We need to adjust. Right now, a war is going on in the neighborhood of Hungary. Hungary is a neighbor of Ukraine. So the current geopolitical situation forces us to prioritize security of supply above any other aspect. That said, this doesn't mean that we should forget about sustainability and affordability. We do not want to compromise on sustainability and affordability for the sake of security of supply and vice versa. We believe that the two things must be achieved together. This is why Hungary is following a pragmatic approach in its energy policy, maintaining our nuclear capacities, which provides large-scale, domestic, low-cost, stable, reliable supply of electricity is of primary importance, which is written in the energy strategy and the energy and climate plans. Nuclear energy is a domestic resource because the facility is within the country, the facility is being operated by a local player, state-owned, Hungarian state-owned MPN. 37% of our power consumption and 44% of our power generation comes from this very facility. We have 4 VVR 440 type units. It's a Soviet Russian technology-based unit with 2 gigawatts of overall capacity that produce about 16 terawatt hours of electricity at a usage of above 90% per annum. On the right side, you can see the power generation, the power consumption, power supply, and generation mix of Hungary since the lifetime of the Paks nuclear power plant. You can see that the share of this power plant is fluctuating between 40 to 50% in the past 4 decades. And this power plant has been operating reliably. It has been providing large-scale baseload electricity for the Hungarian market. With this huge significance of nuclear energy in our power system, and given the fact that we don't really have other meaningful domestic sources of energy, we are committed to the use of nuclear energy. Since without this very domestic, secure, carbon-free power generation method, our climate policy goals are not achievable. So take it out from the energy mix, then how you can support it from other sources, right? This is why, although this facility is more than 40 years old, we have been considering the use of this power plant in the future as well. The Hungarian economy is going towards an electrification, just like any other economies in the EU, and the industrial development also requires additional sources of electricity, so why not getting that delivered from a carbon-free, carbon-neutral source? This is why the Hungarian government made the decision last year to extend the lifetime of the 4 blocks of the Paks nuclear power plant. The lifetime of these units expire between 2032 and 2037. We are now considering an extension by 10 to 20 years, the lifetime of this very facility. But we are not talking about the lifetime extension with regards to our nuclear capabilities. We are also talking about the expansion of these capacities. For this purpose, we are having the Paks 2 nuclear power plant project, which was launched roughly 10 years ago, in order to underpin our growing electricity needs from a carbon-neutral source. This is a project which is in cooperation between the Hungarian state-owned company Paks 2 and the Russian Rosatom. In the framework of this, we are building 2 new VVR 1200 type units next to the Paks nuclear power plant site. This project is a 12.5 billion euro turnkey project, which is currently the largest nuclear power plant project in the European Union with an implementation license. So we're going to have 2 new units with an overall capacity of 2.4 gigawatts. And this very facility, when it would get connected to our grid sometime in the early 2030s, will be able to save 17 million tons of CO2 emission in case we compare it with other fossil fuel power plants. This power plant will underpin our security of supply, reduce our reliance on imports, and will contribute to our climate policy goals. By the way, Paks 2 is not only a Hungarian Russian project, it's a project of broad international participation. It's a fine example of international industry cooperation in the industry, since there are American partners, French partners, German partners among others participating in this project. Opportunities can be, well, SMR can be modular, can be scalable, can support industrial production, heat generation, even hydrogen production, quite scalable, so it is also pretty much needed in the transforming electricity system. Social acceptance, this morning education as a need was mentioned, pretty much we have to agree with that. Social acceptance in the current, sometimes, I would even say very anti-nuclear atmosphere in some countries is pretty much needed. So the review of the whole kind of framework where SMRs can be included have to be addressed, and the framework of international cooperation have to be settled out. So it's the matter of the upcoming couple of years. So generally speaking, technical and economic feasibility of the SMR should rely on safe, flexibility, economics and social acceptance in the societies, and of course that's something to check for the policymakers as well. And our general approach to nuclear energy is, again, green transition is not feasible without the use of base nuclear reactors in power generation. This is our standpoint. And by the way, this standpoint is shared by the International Energy Agency as well. No wonder that nuclear energy is going through its renaissance nowadays. Thank God, most countries, most policymakers are not ideologically driven, but they see the pragmatic need of large-scale carbon-free technologies to generate power. As you can see on the left side, this statistic was mentioned also a couple of times today. More than 30 countries are opening more than 400 nuclear units. Within the EU, 13 countries are operating more than 100 units, and in the globe there are 15 countries that are right now constructing over 60 reactors. And in Europe, thank God, also the non-ideological driven, the pragmatic approach is being followed by most countries. You can see on the map that most EU countries have already acknowledged the need to keep their nuclear fleet, maybe construct some new ones, but at least not to abandon them. There are also some other countries who are willing to enter the nuclear industry, for example, Poland in the EU or Turkey outside.
They want something that would be nice. Actually, this design, we heard an architect from Florida. So this design is the design of our reactor that it doesn't scare people. Now, I told you that in the heating business, everything is about the cost. Yeah? And with nuclear, this is the cost if you use the irradiated fuel depending on the power, and this is the cost if you use the fresh fuel depending on the power of cost. And we can go from 50 megawatt to 100, 150. And if you compare it to natural gas, especially these days when you have natural gas not coming from Russia, but coming from Qatar or LNG, and you have the CO2 credits, you are easily 10 times cheaper. Yeah. Easily 10 times cheaper, but the heating people will tell you we want to have it next year. You don't want to have it in 10 years, you want to have it next year. Yeah. And the second thing, they will tell you, well, maybe you can build it in small cities, and tell them no. Clearly, there's an economy of scale, and this is actually one of the reasons I believe this economy of scale is not valid only for heating reactors, it's also valid for electricity reactors. So that's one of the reasons I believe the electricity reactors in large power units would always be the extent. If you tell somebody I'm going to build the reactor next to you, and there will be some new pseudo-green movement created, mothers of whatever, and they start protesting. So we found out that you have to speak to the local municipalities kind of in secret. They have to do their work, and they need to make the announcement. This is the case study of Pilsen. This is the city of Pilsen, west of Czech Republic, famous for producing beer. And this is their heating station right now, which is actually next to Pilsner Urquell factory, and this heating station is providing cold to this factory. And when we told them, okay, we can give you a nuclear source, but they were suggesting, let's build it here. I thought, well, that's probably not the best idea, right? Building the reactor in the middle of the city, you can see some railroads here, and then you have the brewery here. So that's the thing. You don't need to build a nuclear reactor in the middle of the city. And that's very often the thing with the SMR. So everybody's thinking, let's take a brownfield in the middle of the city and let's put a reactor there. Why? I mean, electricity can be transported hundreds of kilometers. We've got power lines. The heat, believe it or not, can be transported 40 kilometers easily. When you have district heating, you can very easily, by absorption process, like in the skate rink or in old refrigerators, create chill. And there are cities, for instance, Kuwait City or Doha, and they have district chilling systems. So you can provide nuclear source for chilling and chilling the and our strategy is take already existing engineers after the bachelor program and nuclearize them. This is the approach that, for instance, the French were doing with the INSTM program. They take existing engineers after master, and after 1 year they're creating the nuclear. But we're saying we can take mechanical, electrical, chemical engineers at the bachelor level and then create nuclear engineers. And I'm sure we're gonna need not hundreds, we're gonna need thousands of them.
At the end of the 2000s, we had the nuclear renaissance, where there was the idea of more nuclear power construction, more nuclear reactor construction, or life extensions. And then we had the Fukushima accident that stopped all these positive developments for nuclear energy. Now, since 2022, 2023, I guess you all know we have a new situation, at least in Europe. The energy dilemma has shifted a bit. If some countries in Europe before 2020 were focusing a lot on sustainability concerning energy sources and affordability, the aspect of energy security has gone up top of the agenda now. So there has been, I think, a rebalance in energy dilemma, and this has been this has changed the policy of many countries in Europe. Other countries were already pro-nuclear, and those that were not too pro-nuclear were more positive about new developments. So my presentation will be just to tell you about the latest developments, policy developments in several countries. When I say ups and downs, I don't intend to judge the political developments of a country. I'm using that positive and negative about nuclear energy and the impact of nuclear energy. So we start with Belgium. As you can see, 5 units and 41% of nuclear generation. So nuclear power in Belgium has an important role to play. And this has been from a negative development with the decision to phase out nuclear energy by 2025 to a more positive development of at least keeping 2 units operating for 10 more years, or perhaps, if a new government decides so, 20 years. This month, there should be a final agreement for the life extensions of 2 reactors. There are elections in Belgium next year, and as you all know, some countries in Europe have some political coalitions or 3-4 parties that are sometimes complicated. But at least until this year, 2 reactors should see a life extension of 10 years, and that is a positive development for nuclear energy in Belgium. Finland, they don't have a problem with nuclear energy, so to speak, so there is no nuclear phase-out policy like in Belgium. There was one project that was moving forward, but because of the geopolitical situation that we are facing, this project was cancelled. On the more positive side, one large reactor, 1.6 gigawatts, started operating this year. And the government is also more pro-nuclear, so they are looking at the ways that there should be life extensions of the nuclear power, or the nuclear reactors. And the utility Fortum is also working on assessing the possibilities of new nuclear. No final decision yet, but they are taking a look at this possibility. As you can see, nuclear power also plays an important role in the power generation of Finland. The Netherlands, there was a government that was working hard on new legislation and ways of making new nuclear possible. Unfortunately for nuclear power, that government collapsed because of policy differences among the government coalition. And in the recent elections, we don't know yet who is going to be the next government. So how many parties and which parties. But there's a possibility that maybe one political party that is against nuclear energy will be part of the coalition government. And as you all know, when that happens in any political situation, parties make compromises and maybe there is no nuclear or there is less than before. So until some months ago it was positive, now we will see what happens next year with a new government coalition. The nuclear fleet of Netherlands is very small, but they still want to build reactors. And this is also part of the idea of the new energy trilemma and energy security. Spain, I didn't include any apps because there are no apps. They have a coalition government already for many years that is not pro-nuclear, and they have won the elections again, so they are the government. And unless there is no new government in Spain in the future, we will see nuclear power, nuclear reactors being shut down between 2027 and 2035. In this case, the nuclear phase-out policy was not decided by the government. It was the utilities, the nuclear operators that decided it. Because the environment, the way of operating reactors, they had taxes on nuclear energy, on nuclear electricity, so the market environment, the politics was not positive. So the utilities decided on their own, we will have this nuclear phase-out policy. But as you can see, there are several reactors in Spain, which is a higher number than the other countries, and 20% of power generation. So it's also an important power source, but they want to be more renewables, and we will see if there are changes in the future. Sweden, also no nuclear phase-out policy, but because of economics, they have seen a couple of nuclear reactors being shut down in the last years. So the nuclear fleet has increased, but it's still 6 units, 28% of power generation. The positive development in Sweden, there's a new, the positive development for nuclear energy in Sweden. There's a new government there, and they are also assessing the possibilities of new construction, life extensions, also small advanced modular reactors or small reactors. So that's also a positive development for nuclear energy in Sweden. I include in Sweden and the Netherlands also the coalition governments. So the idea is that, as we all know, nuclear power development needs certainty and stability. When you have some countries with 3, 4, 5 political parties in coalition governments, it's complicated. So for nuclear power, it's an additional complication to the ones that we already know about. The next one, Switzerland. In Switzerland, there was a referendum in 2017. The decision was not to phase out nuclear energy, which was positive, but also not to build new reactors. That was the decision of the public at that time in this referendum. So the positive development in Switzerland is that the reactors can operate as long as they are safe. So meaning that now the utilities are looking at life extensions, maybe 60, 80 years. So that's a recent development this year. This can be also considered something positive. My list of other countries is just a number of countries that are. There's a debate about nuclear power, but we don't know what will happen. Norway, there's a company that is looking into small reactors. Italy, they are looking into the possibility of maybe launching a nuclear power program. Denmark is also, there's a company there. Ireland, Portugal. But this is a question rather of just mentioning there, just because to have it in the radar and know that maybe there's something going on. But that's a question. Finally, I think these observations have been already made today. The future of nuclear power is more positive now than 10 years ago. I think we can agree with that one. There are more indicators that there are positive developments. In the context that we have discussed, there's more political support, which is important.
And this is time and Dina You are the chairman of the small modular reactor business in nuclear energy for Rolls-Royce. Do you see growth opportunities for SMR business in the data center sector?
There are huge growth opportunities, and initially when we formed the small modular reactor business, this was really just going to be power on grid to replace coal-fired, oil-fired, gas-fired power stations with sources of net zero energy. Then we saw other opportunities in the chemical industry, in the production of sustainable fuels, in hydrogen production. But about a year ago, the world seems to have changed, and we were approached by lots of the tech companies and data center providers because the growth in data centers, particularly driven by AI, has now meant that they're of the size where they need their own small modular reactors. And the need is very urgent. We've been at a great conference here today where we've heard the need for 38 gigawatts of energy in the next 5 years just to fuel the AI revolution.
How far ahead will SMRs be ready to deploy?
Our current schedule, and we're going through a regulatory process. So nuclear power stations have to go through a regulator that checks for the safety and integrity of the power source. We're planning on going through that over the next 2 or 3 years, then starting to build our first few and getting first power on grid in about 2030 or 2031.
And any indications on the cost of nuclear energy in comparison to other renewable energies?
Yes, so the cost of a power station, and I'll have to start switching between currencies here, is around about $2.5 billion for a 470 megawatt power station. Now, one of the things about nuclear energy is the running costs of nuclear energy are actually quite low, tens of millions of euros a year, and the cost is dominated by the cost of capital, in other words, how much it costs you to raise that $2.5 billion for each power station. Now, with a decent cost of capital, and decent, I'm talking 4 or 5%, we should be able to produce energy at around about 50 to 60 euros a megawatt hour. I'm sorry to switch between dollars and euros. But at that price point, if you include the cost of energy storage, then I think we're going to be undercutting wind. It's true that wind without energy storage can get cheaper than that, but in a real world situation, powering a data center where you need 24/7 energy with 5 nines reliability, you're going to have energy storage if you're using wind as the energy source.
Well, if we're going to meet here in a year's time, what would the story be then?
In a year's time, I think the business would hope to have a far closer relationship with the big data center operators, the big tech companies. I think we can lead them on a path that will mean we can guarantee to get to net zero with a far earlier date than we could if simply they were hoping that the market will provide the electricity at net zero. So really it's about cooperation, it's about partnership, and it's about the energy industry and the data center industry coming together because they need to.
Okay. My guest today.
My name is Sean James, and I lead our data center research and development team at Microsoft.
Lina Tayara, Let's Talk Tech. Well, thank you so much for meeting with Let's Talk Tech today. We're so happy to have you here in Antibes. So data centers, what are they for?
Yeah.
People don't know about them. They don't care very much. How can we bring people into this conversation?
What's made data centers so such a big deal is you're aggregating all of this compute, in a very, very small space that requires a lot of energy and a lot of cooling. But at the end of the day, it's just compute. So we're really agnostic on how these things are powered and how these things are cooled, which is a great opportunity because that means we can pick the best ways to power and cool these things. It's a great time in the industry, not just in the data center industry, but in the energy industry, because there's all these new, wonderful ideas on how to power not just data centers, but power the world, carbon-free, and more sustainable, things of that nature. So it's awesome. I think that there's a great opportunity for data centers and data center industry to help the energy industry accelerate these technologies.
Data center is both the problem in terms of the pollutant as a pollutant and as a weight on the grid, and nobody wants it around them, and it's an ugly building and it doesn't employ many people. So there's kind of a bunch of complaints stacking up against data centers.
Sure.
At the same time, they could be part of the solution in terms of the environment solutions.
So here's the deal about data centers. We build these very expensive buildings, and the power and the cooling is very, very critical. So, like I was saying earlier, it's a great opportunity because the data center industry could be early adopters for all this new energy technology. As a matter of fact, you're seeing it already. What we're doing is we're rolling out renewable diesel. Like, there's all these new things that could happen down the road: hydrogen, small modular reactors, all this like really cool tech, but it could be potentially decades away. So right off the bat, Microsoft and the other hyperscalers have just said, we're going to do what we can now. What's commercially available now? Well, renewable diesel is available now, but all across the gamut, not just with energy, but things like concrete. There's actually more sustainable concrete that you can buy. And so this is just a great opportunity, and the hyperscaler companies like Microsoft have stepped up and said, we're going to be early adopters of this new tech.
So when are we seeing green components get into the construction of data centers? Is this happening, or how long would people keep talking about this, and when will this actually happen?
When will it happen? That's my question. When is it going to happen? So there's things that can be done now, like using renewable diesel, like purchasing low embodied carbon cement for the data center. Like, if you can, use mass timber framing instead of steel. There's all these things that you can do now. There's all these really cool disruptive ideas.
Well, I think this is. I think this would be interesting for our audience, because a lot of the conversation is about having this big mega shift, and it seems like nobody can wave a magic wand at anything, right? So it's nicer to break it down in little steps and little phases for people to start thinking about this. So as we're walking out on this beautiful terrace, you said you want to change the world.
Well, there's a lot of pessimism around the future, but there is some optimism. And what can we do now that we've realized there's a problem, what can we do to sort of shift gears? Climate mitigation, things of that nature. The problem, though, is the timeline. So like I was saying earlier, there's all these new disruptive ideas, and when I ask these companies, how long until I can buy this stuff? At my scale, at a city scale, that kind of stuff. The timelines I see are many decades long. We don't have many decades.
How long do we have to decarbonize?
If there was a solution, next year, we would be all over it. I don't think anybody really knows.
So is this driven by the big tech hyperscalers? I mean, how much of who's doing the driving right now?
Nobody's doing the driving, and that's the problem. And so what the hyperscalers have done is we've stepped up and said, okay, since there's a lack of leadership at the government level, at the industry level, we're going to take on leadership. We're going to start taking the risk of being early adopters, investing in this technology, and trying to get these decades-long timelines down to something that's much more realistic and much more, not realistic, but much that fits within these climate timelines. Here's an example. Lithium-ion battery, when it was invented to when it became, commonplace, 70 years. We don't have 70 years.
No.
So how can early adopters like the hyperscalers, like Microsoft, how can potentially AI as a tool take that 7-decade timeline and get it down to something much, much shorter? It's going to be relevant.
The industry is going to be led or dominated or driven by hyperscalers, edge, or AI. Where's cloud in all this?
Where's cloud? Cloud's been with us for a very long time. Even before cloud was a term, there was still people saving files on the internet and things of that nature.
Yes.
I don't think so. Cloud's kind of a buzzword, like the information superhighway. But these online digital products, these are the things that have been with us and will always be with us.
Hi, this is Lina Taya Let's Talk Tech.
My name is Deborah Andrews. I'm a Professor of Design for Circularity and Sustainability at London South Bank University. Nice to talk to you.
Thank you very much. So Let's Talk Tech is giving visibility to a notable woman in STEM who is integrating environmental sustainability to innovation in design and engineering. Professor Deborah Andrews is a professor in sustainable design and manufacture in the School of Engineering at London South Bank University. She supports the data center industry, an industry that emits the same amount of carbon as the airline industry. She supports this industry to transition to an environmentally sustainable model. Welcome, Professor. Please tell us about you and tell us about what you're doing.
Okay, so my background originally, I studied product design and industrial design as under and postgraduate student, and then started working and eventually ended up here at London South Bank and moved from quite conceptual design into more technical design and became increasingly interested in environmental issues. So over the years, my work has focused more and more on environmental factors and trying to identify ways to improve the environmental footprint of products, services and systems. And in, let me think, 2010 or 12, I was introduced to the data center industry by Robert Tozer, who's a professor here as well, a visiting professor. And I first supervised a PhD program, which was building the first life cycle sustainability assessment of data centers. And what we wanted to do was to identify the real hotspots, the real problem areas, because the industry then and now, believe it or not, you know, kind of 10, 12 years on, is still focusing on operational energy efficiency. And that is not enough. The data center industry has expanded exponentially and is going to continue to expand because of the demand for compute, etc., in relation to AI. And we really need to think about materials and embodied impacts of equipment, most of which is designed in a linear fashion. In other words, we take resources, we make stuff, we use it, and we don't think about what's going to happen to it at end of life. And it's a very, very big problem with electrical and electronic products. And in fact, waste electrical and electronic equipment is the fastest growing waste stream in the world. And the data center industry is contributing to that. So we've all become, I would say, I guess, addicted to use of digital technology, which of course the data center industry supports. But we really need to think about the embodied impacts of all the equipment in the industry that enables us to access digital information and communication, etc., whenever we want. So for the past few years, I've been I was the founder and leader of a project called Zedasi, which is kickstarting a circular economy for the data center industry. So instead of designing products that are just where we take, make, use and dispose of them, we actually think at the design stage about what is going to happen to products at end of life. How can we change the design of products so that they can be easily and economically disassembled and materials can be, and components can be separated to increase recycling rates? How can we also extend product life? Because an awful lot of equipment in the data center industry is taken out of service when it still functions very, very well. So we're looking at all of life in the project, taking a whole systems and whole life approach to the challenge of data center sustainability. So we're looking at the beginning of life, the design phase, middle life, if you like, product life extension, and then what happens to stuff at end of life? How can we improve recycling and reclamation of materials? And as I already said, the sector is expanding rapidly. And in fact, I've read that in order to accommodate the compute required for AI, the sector is going to have to expand provision by, it's going to have to treble basically by 2030. So the need to design better, more circular equipment, i.e. equipment that can be easily disassembled, recycled, etc., or repaired and reused. We need to do all of that to ensure that the data center industry can function as we want it to function.
Can you get us up to speed on the, I mean, I know you're not just involved in academic research, you are actually also connected with the industry. And that, you know, you have quite a complete, wholesome picture of what's going on. So if you connect the dots in an integrated way, can you get us up to speed with the latest thinking, integrating research with your expertise inside the tech and the data center business to accelerate the circular economy and incorporate environmental best practice in design thinking? Where are we at here? Can you give us this situation analysis?
Okay, so I think in some respects there is a bit of a gap between academia and the industry, and I see part of my role is to find ways to help industry to appreciate the scale of the problem that it's facing, and to present empirical evidence to show the scale of the problem, but also empirical evidence to show how a change in business practice, etc., can actually improve company profiles. Now, one of the big challenges is, of course, that companies are focusing on carbon reduction mainly in relation to operational energy, which is really important. But to date, there haven't been any tools or any way of demonstrating the embodied impact of products and so forth associated with this sector. So through the SEDASI project, we've collected a huge amount of primary source data and built a tool, the Circular Data Center Compass. And that was developed specifically to help industry and stakeholders to make really informed decisions about the equipment that they buy, what they do when equipment appears to be reaching in industry's perception end of life. Can it be updated? What are the advantages of refurbishing and so forth? So this tool was developed specifically in conjunction with representatives from the industry. The SEDASI project was funded by Interreg Northwest Europe, and one of the remits of that funding stream is to work with industry directly. So we are basically, as an academic institution, offering the industry services that they wouldn't necessarily have access to. So our project started by talking to representatives from all the different industry subsectors, because I'm sure many people are aware that the data center industry is comprised, well, we worked out there were 14 subsectors, but people, experts, phenomenal levels of expertise, but people working in silos, and they don't talk to people in the other subsectors. So they're doing the best that they can within their sphere, but without really understanding the impacts that their decisions have on other aspects of industry. So we started by bringing together representatives from the various subsectors across the industry, and we ran co-creation workshops, which are talking shops in a way, but guided discussions to really identify what representatives of the industry wanted in terms of a tool. What would they, what sort of answers would they like the tools to provide? So right the way through the project, the conversation continued. So we had the initial co-creation workshops, then we developed the tool, and I mentioned before, it's all based on primary source data, which is very different to most other tools, which are based on secondary source data and assumptions. So we believe that our data sets are much more robust. But then again, going back to industry, we organised meetings so that they could test preliminary versions of the tool and give us feedback. So it was very much a sort of co-creative an evolutionary process until we launched the tool a few months ago.
Right. So looking forward, is 2024 a year where business will invest and experiment with decarbonization solutions?
Well, this is the million-dollar question, I guess. I would like to think so. From our experience working with and meeting representatives of the sector, they tend to fall into two camps. People who get what we're trying to do and open to learning about possibilities for change and so forth, and people who really reject the idea without really understanding what's going on. So, for instance, when we give talks at industry events, and I'm regularly presented at Data Center Dynamics, Data Center World, Open Compute Foundation, and last summer I had the fantastic opportunity to go to Antibes for the Platform Markets event, talk to people in industry.
We have grown to be wasteful consumers as individuals, as enterprise, and as industry. It seems a big behavior change or a shift needs to happen towards the practice of recycling and accepting that recycled products are fit for purpose. Why should levels seek care, and where should they start?
Well, this is behavior is part of the challenge, but also having an adequate infrastructure to take equipment and recycle it properly is an even bigger challenge, or at least equivalent to behavior change. So it's very easy for somebody sitting in industry to say, right, I'm going to, tick my boxes, my CSR boxes, etc., and also to conform to legislation, and a recycling company will come and collect my equipment and take it away and deal with it. So, and that does happen a lot in data centers, but unfortunately, quite a lot of the recycling companies are, well, some of them, I would guess, are doing the best that they can, but that's not enough. So at the moment, the main materials that are recycled from equipment, anything with iron in, steel-based materials, copper, aluminium, and gold, and that's it. And in circuit boards, printed circuit boards, for example, there are up to 12 critical raw materials, which if we don't have those, we don't have a data center industry or any digital communication. And they're called critical raw materials because of the amount that is left in the earth that hasn't yet been mined, the recycling rate, which currently is less than 1%, which is a bit shocking, the ability to substitute materials, but also, and this is really important, the location where the reserves are found, and a lot are in geopolitically sensitive areas. So those four factors together mean that these critical materials, which are of high economic and technical significance, most of them are being wasted. They're dumped in landfill and so forth at end of life. Now, so we need to kind of push and pull from both ends of the data center industry. It's fine for the stakeholders to say, we're doing our bit. We get recycling companies to come and take our kit away. But at the moment, there isn't the incentive to build adequate recycling facilities to process all the equipment that is, ready for recycling, etc. And in addition to the scale, we also need to develop facilities that can recycle and reclaim many more materials than are currently recycled.
So how can we reduce dependence on raw materials in favor of recycled materials? And do you see a new market for second life equipment in data centers, similar to the aviation industry and textile industries, where recycle and reuse have grown into an industry in and of themselves? Is there a geographic area or company or a country that is advanced in that way from their policy perspective or from best practice perspective?
Yeah. From policy perspective, in terms of, well, we call it second life or extending product life, because as you know, so many pieces of equipment are taken out of service and replaced with new simply because they've got more, tiny bit more compute capability when actually they function very well. So the secondary market is slowly developing. There are quite a number of practitioners or companies involved in promoting that, be it sort of basic cosmetic refurbishment or more serious technical upgrades and so forth in various parts of Europe. And there is a non-profit organisation called Free ICT Europe, for example, who are campaigning and pushing for better support for that secondary market. Because at the moment there are issues around, for example, warranty, etc. So there's a real drive. There's very definitely in certain sectors, I don't think, although the OEMs aren't terribly happy about it, but there's a real drive to increase that market share, because not only can it save purchasers money, but it also has a very significant environmental benefit, of course, because you're keeping materials in use for longer. You're not mining raw materials.
If we were to approach the circularity issue from a supply security perspective,
that's a really good point. I think that if you think about energy efficiency, that was driven by legislation. There hasn't been any legislation so far related to physical resource efficiency. So, there's only goodwill rather than, as a carrot rather than a stick to kind of encourage that. But I would say that having been to Antibes, to the markets event, that there's masses of opportunity and really fantastic investment opportunities for maybe data center companies to think more holistically, not just about building sites, running them, and then somebody else deals with all the waste, blah, blah, blah. But actually thinking, well, maybe we should start thinking about investing in recycling capabilities in Europe and extending. There are a few recycling plants, but they're very limited. And developing that, it could be a great business opportunity. And maybe you could actually have circular businesses, where the good thing about having localized recycling and so forth would mean that the materials there's less possibility of materials being contaminated, which means that when they go through the recycling process, hopefully they'll be purer and then much, much easier to use for, manufacturing new products. The great thing about metals is that when you recycle them, in theory, you could do it ad infinitum. They're really stable. Plastics are a completely different kettle of fish. They are synthetic. They were designed, developed for very specific functions, and they perform, that first life function brilliantly. They don't decay, of course. We know we've got a big problem with plastic waste. But when we recycle them, they lose a lot of the inherent properties that they had when they were first manufactured. So you can't necessarily use them for the same product again. You might be able to use it for a lower grade product. But metals, and there are a lot in service in particular, they have the highest environmental impact of all data center equipment, partly because of the materials that are used to build them, but also because of their comparatively short life. So, there's lots and lots of potential to make a kind of whole product life or equipment life system. It just needs more creative thinking and people who, we hear about people working in the City of London or Frankfurt or wherever who take risks, calculated risks all the time. I would think that actually building really good recycling capability for electrical and electronic equipment, the risk is pretty low because the demand for the materials is going to increase. It's time to quote Greta Thunberg and say, blah, 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 no more blah, blah, blah. Let's have some doing.
Are sustainability pledges sustainable in 2024?
As long as the pledge is turned from intention into action and reality, then yes, it's important. And let's I'm full of admiration for the people who stick their necks out and take risks in terms of sustainability. That they're trailblazers. They show by example. And I think it's time for more people to take risks in the data center sector. It makes a lot of money, it uses a lot of resources, And I think that the sort of responsibility, environmental, social responsibility, there has to be a trade-off for the economic gain there. So.
Professor, it's been an absolute honor to meet you today. Thank you very much.
Well, thank you for taking the time to interview me.
Thank you for our audience to follow up on our circular economy. This was Lino Tayara, Let's Talk Tech.
And Deborah Andrews. Thank you very much for listening. Thank you.
Monsieur Thierry Chamaillou, quel plaisir de vous avoir avec nous aujourd'hui.
Plaisir pour moi.
If we are moving from a cloud era to an AI era, will enterprise spend be directed away from cloud services?
It's an interesting question. Thank you for asking it. Now, Lina, to be honest, it's a very interesting question because there are a few things that we're aware of, and a few more that we have a feel about. I truly believe that AI is going to happen more at the edge, and rightly saying your question is spot on. Is that going to detract or attract, or is that going to move volume, fluxes of business from one way to another? So as I said, I think that the best equipped vehicle is what lies at the edge. I am not sure that the very first move that we're going to be seeing on AI kicking in are going to be as structured as the way we see it into the DCS business, because historically speaking, we've been building and growing on the data center business from local to regional to massive data centers and the co-location. So we've had the time to build it up. I think that on the AI, it could be a lot of data come rough and dirty, and that we have to cope with. And there is nothing wrong in what I'm saying rough and dirty, is because it's a huge amount of data coming in the same time, not being judgmental. And where is the best equipped is edge, because you need to have that data compute at the closest where that data is being created. Now, is this going to take away from? I don't think so. What would be interesting to figure out is this something which is really considered part of the normal data center business that we see?
Yeah.
Because the normal data center that we see, we can read all the reports that saying that it's going to keep on growing and growing and growing. And interestingly enough, you don't need AI to grow. You're going to be growing massively, but that AI is going to happen irrelevant. So are you going to be, really chipping in to figure out that it's something that you're going to go for, or are you going to let it happen at the edge first and then get it to somewhere else? That somewhere else, I don't know where it is right now, but it's interesting.
What is your perspective of the data center market in EMEA region over the next 5 years?
So I'll tell you, I am so happy that I'm in that, part of the world. We tend to look at, in Europe, Middle East, and Africa, it's very interesting, again, because what is true in Europe is not yet true in Africa, is not yet true, and might never be true in Middle East. And I think that, where you would believe that, for instance, yes, we've heard that 1,000,000 times before. What's happening now in Europe will happen in 5 years in Africa. All wrong. All wrong. I am a firm believer of the reverse psychology and the reverse engineering. I think that in Europe, one of the key elements of the growth for Europe is coming from what we can learn in Africa today.
Yeah.
And Middle East comes with a different angle to the business. First, because of the sequence. Second, because of the nature of the business. Third, because of how the investment is happening in Middle East.
And that has nothing to do on how the business is being financed in Africa. For instance, in Africa, endemic business will happen. It's inevitable. You've got the demography, you've got the age of the African youth, and they're all tech savvy. So it's inevitable. Now, that business cannot be a business where historically, back in the agricultural day or the industrial days, you would invest in Africa, suck out the money of Africa, and keep on doing your business somewhere in the US or in China or in Europe. This is no longer valid. So we need to find a model where in Africa, most of the business that we're doing that creates revenue, value, is going to stay in the country. All right? The rest can be happening because the players, we know the players, who are the internet giants. You know, they're 21, 22 internet giants, or players, I would say, from the US or from China. You cannot live and have a business model where you're not going to stay with some of the value that you create. You won't be. You have to let it stay in Africa. So it's very interesting, because that's exactly something that we've done in Europe. Never ever we've been taking out the business and value that you create in France or in Germany or in Spain, and then you take it back home, ever. And that is going to be changing the paradigm, because Africa historically has been the place where people come and do business, and they don't especially stay there. So that business that is coming now is something where I truly believe that is going to stay. So to come back to your first question, it's going to keep on growing. And I suspect that it's going to grow faster than what we see and what we read absolutely everywhere. And everything which is new is good to learn. So that's why I'm excited. I'm going to learn more.
If we are to meet here same time next year, what do you think would be a closed file that we discussed today? It would be like, okay, it's a given. And what would we be talking about next year, this time next year?
With the current energy crisis that we're going through, will provide the impetus for accelerating that electrification. The outcome of us being able to reduce our carbon footprint, our emission, which at the end of the story is saving our planet for the next generation, that is so important that I would like that presentation not to be repeated, because it's been taken, understood, and we've moved on.
Tom, you're doing something very interesting in terms of CSR and something to do with bees. And just as the digital infrastructure and data centers are getting more into the CSR space, can you tell us about your particular initiative, how you're helping the ecosystem?
I think you spotted it earlier, my DCs for Bees label pen. What we do is we plant orchards for the community around Ireland to help with bees when they start coming out of hibernation in winter. They pollinate the trees to encourage the diversity and to bring our bee population back to life, because it's been in decline for a considerable number of years. And in Ireland, Host in Ireland are the leaders of this industry initiative, which involves planting orchards for the community around Ireland. And this year we're looking to plant 5 orchards starting later this month.
Fantastic. And can you share with us the value of this investment?
Well, first and foremost, it's good corporate social responsibility. It's tangible, and it involves us getting involved. It's not us writing a check like many other big corporations are doing, and plenty other corporations could do a lot more to get us hands-on, where we go out, we find schools, parks, workplaces, to get some green space. We only need 15 square meters to plant an orchard. We go out, we plant the trees ourselves, maintain them and bring them to life, and to make sure they're within proximity for the bees to be able to find them and to pollinate them.
So now moving away from your social responsibility, which is a fantastic initiative, to engage your local community. I wanted to get into something more technical. There's been a lot of talk about liquid cooling, especially in the context of the energy-hungry AI-enabled data centers. Can you tell us from a construction perspective what that entails? What do data center designers and builders and engineers and architects need to bear in mind?
Well, first of all, we're very fortunate in CAI. Our company was founded by retired naval submarine officers. So we have a lot of experience in these types of initiatives that they would, and a lot of the people who come to our company are ex-naval officers, where underwater initiatives or water cooling, as it's known in data centers, would have been pioneered and would have been tried and tested in some of the facilities that our operators were working on before they came to the organisation. I myself have been involved in one facility in Finland where it is bringing water in from the ocean and pumping it into the data centre for cooling purposes. And obviously the Baltic Sea, as we know from using the term, it's Baltic, is very, very cold. So it's reducing their costs significantly because the water is already chilled. They don't have to chill the water, so they're not burning more electricity or energy to chill the water, and they're bringing it into the data centre to keep it cool. That now is being continued on because it's been a massive success in one hyperscale client in particular. I can't name them obviously for NDA reasons, but it has been significantly successful, and the fact that we have been involved in facilities in Europe and in the United States of America with underwater cooling systems, we're now in an ideal position to advise designers, clients, general contractors, and when we're on site commissioning them ourselves, we have a very good working knowledge of these systems and how they work.
So in terms of the, okay, so you talked to us about water cooling in areas where nature helps a little bit with the design and the infrastructure. What about countries in the Middle East where you have, the infrastructure is different, right? You have deserts and it's hot and you have humidity and water scarcity.
Yeah, funny as you mentioned that we've been appointed to a very significant project in the Middle East, and again because of NDAs I'm not able to disclose part of it, but it is in Kuwait, and where there's scarcity of water and where it is very, very hot, you're looking at submersing the data center deeper into the ground, using the ground as a cooling system, so have it more underground, and then obviously it's the air handling then. It's getting the hot air out of those rooms, but you will have a cooling effect from having the data center dug deeper into the ground in those areas.
Okay, and any thinking in terms of the heat reuse from that site, or about alternative energy, or is this going to be mainly plugged on into the grid?
Well, we put forward from our experience in the EMEA region, in the APAC region, and in the United States, we put forward a number of alternatives. Obviously, the heat can be recycled and can be used in other facilities, like in the Netherlands. They're heating swimming pools and heating apartment buildings from the waste heat coming from the data centers. And it's about exploring what opportunities are available in there, as in where can we bring the heat from the data center close to the localities nearby.
So Tom, now the name of the game is innovation, even in construction, because you have to slightly be in tandem with the evolution of the data center and the whole ecosystem. So what are you doing with regards to innovation? Anything that is noteworthy for us to know about?
Sure. Well, obviously we're always looking for a competitive advantage. We're always looking to deliver new ideas for our clients, and there's a saying that goes, innovate or evaporate, and we've no intention of evaporating. We have designed a new system for the safety management and carrying out of lockout tagout during construction and in data center infrastructure management. Lockout tagout is controlling the hazardous energy discharge, where it can lead to loss of life if people get electrocuted, to equipment being damaged, and can cause huge delays from planning the lockout tagout and managing it and undoing it. So it can be a logistical challenge for the construction team, but we've pioneered a digital app and digital twin that's on a PC based, and it's off a cloud-based system that it manages the lockout tagout system. We trialed it on a 30 megawatt data center in Ohio in the United States of America, and we reduced the installation costs and the lockout tagout costs by over $2.9 million on a 30 megawatt facility, and that client is obviously instructed us to install it on all their facilities from now on. So it's not in its infancy. It starts maturing in the United States of America, but it's in its infancy here in Europe. But we are developing it and we are installing it in a significant number of hyperscales and co-locations.
Amazing. So any last word in terms of what are we likely to hear from you next year in terms of projects?
Hopefully we'll have new clients, and our existing clients will be commissioning their data centers in new geographic regions in the EMEA area where we're working in. And I will definitely have significant improvements on our auto-lotto system. We already have some new advanced features to be installed in it, and also you'll find that it will be mainstream in data center construction, and obviously wider as well, because the benefits of it are being seen in other construction sectors.
Well, Tom, thank you so much.
You're welcome,
for being
Nina.
on Let's Talk Tech, and we look forward to hosting you again in the future.
Thank you very much.